The summer I turned 53, I accepted a temporary reassignment to the Gila National Forest in southwestern New Mexico. This would have been August of 2011. I'd spent the previous 4 years working stations in the Pacific Northwest, mostly northern Washington, and the transfer south came at my request. My knees had started talking to me during the wet season, and I thought a few months in dry country might do them some good. The Gila is roughly 3.5 million acres of canyon, mesa, volcanic rock, and ponderosa pine, and it contains the first land in the United States ever designated as official wilderness. Aldo Leopold himself pushed for that designation back in 1924. The place has history written into the ground. I arrived at the Wilderness Ranger District station outside the town of Glenwood on the 2nd of August. The district ranger was a woman named Corinne Sandoval, early 40s, who had been running that station for 6 years and knew every drainage and ridgeline in her jurisdiction with the kind of familiarity most people reserve for the rooms of their own home. She was direct without being cold, organized without being rigid, and she had a habit of listening to everything you said before responding with about a third of the words you expected. I liked her immediately. If you're the kind of person who finds yourself coming back to these stories, who wants to hear what actually happens in the places most people only drive past, you might consider subscribing. I've got plenty more to tell. The reason Corinne had requested additional experienced personnel that summer wasn't complicated, but it was unusual. Over the previous 14 months, the district had logged an abnormal number of incidents along a particular corridor of the Gila Wilderness, a stretch of deep canyon country centered around a tributary called Redstone Creek that fed into the middle fork of the Gila River from the northeast. The incidents varied in type and severity, but collectively they had created a pattern that was difficult to dismiss. 3 separate backcountry hikers had walked out of that corridor over the course of a single year, claiming they had become disoriented in ways they could not explain. One of them, an experienced thru hiker with over 800 miles on the Continental Divide Trail, had been found by a volunteer SAR team sitting beside a creek he had crossed twice before, unable to articulate which direction he had come from. His compass was functional. His map was in his hand. His GPS unit showed his exact position. He simply could not make the information connect to the landscape around him. 2 other hikers, unrelated, months apart, reported similar experiences in overlapping areas. Both described a sense of spatial confusion that onset rapidly and without warning. Neither had any prior medical history that would explain it. Neither was dehydrated. Neither was running a fever. One of them, a woman in her early 60s who had been hiking the Gila for over a decade, told the ranger who debriefed her that she had stopped on the trail, looked around at terrain she had walked dozens of times, and felt with absolute certainty that none of it was where it was supposed to be. Not that she was lost, she clarified, that the land itself had shifted. Corinne documented everything carefully. She consulted with the regional office. They discussed possible environmental explanations, magnetic anomalies in the volcanic rock, localized gas seepage from geothermal activity, even carbon dioxide pooling in the canyon bottoms during still air conditions. The Gila sits on volcanic terrain. Hot springs feed into the river system. Geothermal venting is not unusual in that part of New Mexico. Any of those explanations could theoretically produce disorientation, nausea, or confusion in someone spending extended time in a poorly ventilated canyon. But then there were the other incidents. In March of 2011, a pair of college students on spring break had camped near the confluence of Redstone Creek and a smaller unnamed drainage about 4 miles upstream from the Middle Fork. They hiked out a day earlier than planned and reported to the ranger station that during the night, something had moved through their camp. Not an animal, they said. They had hung their food properly. Nothing was disturbed. But both of them woke independently, roughly 20 minutes apart, to the sound of footsteps circling the tent, in a pattern that one of them described as mechanical, evenly spaced, unhurried, consistent rhythm. When the first one woke his friend, and they both listened together, the sound continued for another 4 or 5 minutes, then stopped. They did not unzip the tent. In the morning, they found no tracks. The ground around the campsite was a mix of alluvial gravel and dry silt, the kind of surface that holds impressions well. There was nothing. In May, one of Corinne's own seasonal rangers, a young man named Devin Park, who was in his second summer at the district, had gone up Redstone Creek on a routine trail condition survey. He was supposed to hike in 12 miles, assess several water crossings, and 2 sections of trail that had been damaged by winter runoff, and hike back out over 2 days. He completed the survey without incident, or so he reported initially. But when Corinne reviewed his written report, she noticed he had skipped an entire section. A 2-mile stretch between what the district maps labeled as waypoints R7 and R9. When she asked him about it, Devin told her the trail through that section was in the same condition as the rest. When she asked why he hadn't documented it, he paused for a long time and then said he didn't remember walking through it. Corinne pressed him. Devin was not the type to cut corners. He was meticulous. He was the kind of seasonal ranger who actually enjoyed paperwork because he believed accurate records mattered. After a long conversation, he admitted that he remembered reaching waypoint R7, which was a cairn marking the junction with an old mining spur trail. And then he remembered being nearly a mile past R9 with no recollection of the ground between. He had not fallen. He had not slept. His pack was still on. His GPS track, when she downloaded it, showed continuous movement through the missing section at a normal hiking pace. But the track showed something else that neither of them could explain. Between R7 and R9, his pace had been almost perfectly uniform. Not the natural variation you see in someone walking rough terrain, faster on flat ground, slower on climbs, brief pauses at obstacles. His GPS showed a nearly constant speed of 2.4 miles per hour for the entire stretch, as though he had walked it mechanically, without responding to the landscape at all. Devin asked Corinne not to include that detail in the official trail report. She included it anyway, in a separate internal memo that she filed with the district's incident log. She did not hold it against him for asking. She understood. There are things that happen in the field that resist professional language, and sometimes the instinct to leave them out of the record isn't dishonesty. It's self-preservation. When I arrived in August, Corinne laid all of this out for me on my second day. We sat in the station's small conference room with a topographic map of the Redstone Creek corridor spread across the table. And she walked me through each incident with the same methodical patience she applied to everything else. She had printed copies of every report, every GPS track, every debriefing transcript. The folder was almost 2 inches thick. "I'm not asking you to explain any of this," she said. "I'm asking you to go up there with fresh eyes and tell me what you observe. You've got more field time than anyone else I could get on short notice, and you don't have a history with this drainage. I need someone who doesn't already have a theory." I appreciated that. Most district rangers, when they bring in outside personnel for something unusual, either oversell the mystery or undersell it out of professional embarrassment. Corinne did neither. She gave me the data and asked for observation. That's the best kind of assignment. She paired me with Devin Park, who knew the terrain, and with a woman named Marguerite Laval, who went by Maggie and who was not a ranger at all. Maggie was a geologist from New Mexico Tech in Socorro. Corinne had contacted the university's Earth Sciences department back in June, after the Devon incident, and asked whether anyone on faculty had interest in studying possible geothermal or geological influences on human cognition in volcanic canyon terrain. Maggie had practically volunteered before Corinne finished the sentence. She was in her late 30s, built like someone who spent more time on rock faces than in lecture halls, and she carried herself with the particular confidence of a person who believed every strange thing had a physical explanation waiting to be measured. The plan was straightforward. The three of us would hike into the Redstone Creek corridor, establish a base camp near the confluence where the college students had reported the circling footsteps, and then spend 4 days conducting a systematic survey of the drainage between waypoints R5 and R11. A span of roughly 8 miles that contained every location associated with the reported incidents. Devon would handle trail assessment and navigation. Maggie would take air quality samples, measure magnetic field variance, test for carbon dioxide and hydrogen sulfide concentrations, and monitor barometric pressure at multiple elevations within the canyon. I would observe, document, maintain communication with the station on our scheduled radio checks, and watch for anything that didn't fit. We left the trailhead at 6:15 in the morning on August 5th. The temperature was already in the low 70s, and the forecast called for clear skies with afternoon thunderstorms possible by midweek. Standard monsoon season weather for the Gila. The first 4 miles of trail followed the Middle Fork upstream through a wide, sun-exposed valley where the river braided over pale gravel bars and cottonwoods lined the banks in heavy green rows. We crossed the river 3 times in that stretch. The water was shin-deep and warm. Maggie commented on the mineral smell, faintly sulfuric, which she said was consistent with upstream hot spring input. Devon led at a comfortable pace, and we made easy conversation about the terrain, the district's summer workload, and the particular challenges of maintaining trails in a wilderness area where mechanized equipment was prohibited. Devon was 26. He had studied forestry at Northern Arizona University and had spent 2 seasons with the Forest Service before transferring to the Gila. He was quiet by nature, but not withdrawn. When he spoke about the landscape, he did so with genuine affection, pointing out specific trees he recognized, naming the side canyons as we passed them, identifying bird calls without being asked. He did not bring up his experience between R7 and R9. I did not ask. There would be time for that later, and I wanted to see the terrain before I heard it described through the filter of someone else's unease. Maggie talked more freely. She explained that the Gila country sat atop the remnants of a massive volcanic caldera system that had been active millions of years ago, and that the geothermal features, the hot springs, the warm creeks, the mineral deposits, were essentially the last whispers of that ancient volcanism. She described how certain volcanic formations could produce localized magnetic anomalies strong enough to interfere with compass needles, and how pockets of carbon dioxide heavier than air could pool in low-lying areas, particularly narrow canyons with poor air circulation, and produce symptoms ranging from mild confusion to unconsciousness depending on concentration. She was methodical in her explanations, and clearly excited about the opportunity to collect field data in a drainage that hadn't been formally studied. Around mile 5, we turned northeast off the Middle Fork Trail and followed the Redstone Creek tributary upstream. The character of the landscape changed almost immediately. The wide valley closed into a narrow canyon with walls of dark volcanic tuff rising 60 or 70 feet on either side. The creek itself was small, maybe 4 feet across and ankle deep, but the canyon it had cut was disproportionately large, suggesting that at some point in geological history, much more water had flowed through here. The vegetation shifted too. The cottonwoods gave way to box elders and narrow-leaf willows crowding the creek banks, with ponderosa pines clinging to the upper slopes wherever enough soil had collected in the rock. The light changed. Where the valley had been bright and open, the canyon filtered the August sun into angled shafts that reached the creek bottom only for a few hours in the middle of the day. Devin slowed his pace here. Not dramatically, but I noticed. He checked his GPS more frequently. He began pointing out waypoint markers, the small aluminum tags nailed to trees at approximately 1-mile intervals, with a precision that felt less like navigation and more like reassurance. R3, R4. The trail was in decent shape, narrow but passable, hugging the creek bank and occasionally climbing over small rock shelves where the canyon wall pushed in close to the water. We reached the confluence with the unnamed side drainage around noon. This was the area where the college students had camped, and it was easy to see why they had chosen it. The canyon opened slightly at the junction of the two drainages, creating a flat bench of packed gravel and sand roughly 40 feet across, shaded by a cluster of old-growth ponderosas. The creek split around a low gravel island before rejoining just downstream. It was a natural campsite level ground, water access, overhead cover, and enough space to feel comfortable. We dropped our packs and ate lunch. Maggie immediately began setting up her first sampling station, pulling instruments from a padded case with the efficiency of someone who had done this hundreds of times. She placed a carbon dioxide sensor at ground level near the creek, a second one at waist height, and a third on a low branch about 6 feet up. She explained that CO2, being heavier than air, would show higher concentrations at lower elevations if it was pooling, and that the gradient between her 3 sensors would tell her whether gas accumulation was a plausible factor. Devin sat on a rock near the creek and studied the map. He traced the route upstream toward R7 with his finger and didn't say anything. I walked the perimeter of the campsite slowly, examining the ground, the tree trunks, the rock faces on either side of the drainage. I wasn't looking for anything specific. I was building a mental inventory of the space, what belonged, what was where, what the baseline condition looked like before we spent 4 days in it. That habit had saved me more than once over the years. You can't recognize what's changed if you don't know what was there to begin with. The gravel bench showed no sign of the college students' camp. 5 months of monsoon rain and creek fluctuation would have erased any trace. The surrounding terrain was unremarkable. Dry volcanic rock, scattered deadfall, a few patches of scrubby oak on the south-facing slope. I noticed one thing worth noting. The walls of the side drainage, the unnamed one that entered from the northeast, were darker than the main canyon walls, almost black in places. Maggie had mentioned that certain volcanic formations contained high concentrations of magnetite, and the color difference could indicate a compositional change in the rock. I made a note of it and moved on. We set up camp efficiently. 3 tents spaced about 15 feet apart on the gravel bench. A cook area downwind. Food bags rigged to hang from a high ponderosa branch. Black bears were active in the drainage, and the district had also documented a resident mountain lion in the broader watershed. We established a latrine site well away from the creek per standard leave no trace protocol. By 2 in the afternoon, we were operational. Maggie's CO2 readings from the first hour showed nothing unusual. Ambient levels at all 3 heights, within normal variation. She seemed neither surprised nor disappointed. "First sight, first hour," she said. "The data I need will come from the narrow sections upstream, especially if we get a still night." Our first scheduled radio check was at 5 o'clock. I keyed the handheld and raised the repeater on the first attempt. Corinne answered from the station. I reported our position, confirmed base camp was established, gave a brief condition summary, and confirmed our plan to begin the upstream survey the following morning. The radio worked cleanly. No static, no interference. I noted that too, because one of the earlier incident reports had mentioned intermittent radio difficulty in the upper drainage, and I wanted a baseline for our own communications. We spent the rest of the afternoon in unhurried preparation. Devin organized his trail assessment kit clipboard, camera, measuring tape, flagging ribbon. Maggie calibrated a portable magnetometer she planned to carry upstream, explaining that she wanted to map magnetic field intensity at regular intervals along the creek to identify any anomalous zones that might correspond with the disorientation reports. I reviewed the incident file Corinne had given me one more time, cross-referencing each reported location with the topographic map and marking them with small pencil dots. When I spread them out on the map, the dots formed a loose cluster. Not random, but not perfectly concentrated either. They centered on a 2-mile stretch between R7 and R9, but several of the disorientation reports originated from locations a half-mile or more outside that core area. If there was a single-point source for whatever was affecting people, its influence was either mobile or it radiated outward in ways that weren't uniform. Dinner was simple. Freeze-dried meals reconstituted with boiled creek water. We ate as the light drained from the canyon, which happened fast. By 7:30, the sun had dropped behind the western rim, and the canyon floor fell into deep blue shadow, while the upper walls still glowed amber. The temperature dropped 15 degrees in 20 minutes. Desert canyon country does that. The rock absorbs heat all day, and the air above it stays warm. But the moment the direct sun disappears, the shaded air at the bottom cools rapidly. Maggie noted that this thermal inversion, warm air above, cool air below, was exactly the kind of condition that could trap heavier-than-air gases at creek level. Devin was the first to bring up his experience. We were sitting around the cook area, headlamps off, letting our eyes adjust to the dark. And he said it without preamble. You should know what it felt like, not just what the GPS showed. I told him I was listening. I remember coming around a bend in the creek and seeing the R7 cairn on the left bank. It's a good-sized stack, maybe 3 feet tall, with an aluminum tag on the top stone. I remember thinking I was making good time. I checked my watch, and it was 11:40. I remember that specifically because I was calculating whether I could make R9 before my lunch stop. He paused. And then I was past R9. My watch said 12:22. The math works out for continuous walking at my normal pace. Nothing about the timeline is wrong. But I don't have any memory of that stretch. None. It's not like I was distracted and the time flew by. It's not like I was zoned out on a long highway drive. It's a complete absence, like those 42 minutes were removed. Maggie asked him whether he'd experienced any headache, nausea, ringing in the ears, or visual disturbance either before or after the gap. Nothing, Devin said. I felt fine. That's what bothered me more than anything. If I'd felt sick, I could have told myself it was heat exhaustion or low blood sugar or something. But I felt completely normal. I just didn't have the memory. And your GPS track was continuous? Maggie asked. Corinne showed me. Continuous, steady pace, no stops. That's consistent with an altered conscious state rather than a loss of consciousness, Maggie said. If you had collapsed or stopped, the GPS would show it. You were ambulatory and navigating. You just weren't encoding memory. Transient global amnesia, I said. Maggie looked at me. I'm not diagnosing anything, I said. I had a SAR case in the Cascades about 10 years back. older gentleman who went out for a day hike and was found 6 hours later sitting on a rock 3 miles off his route, with no memory of leaving the trail. The paramedics mentioned transient global amnesia as a possibility. Rare, usually resolves on its own, sometimes triggered by physical stress or sudden temperature change. "It's a reasonable differential," Maggie said. "But TGA typically presents in people over 50 and is usually accompanied by repetitive questioning. The person asks the same thing over and over because they can't form new short-term memories." Devin was 25 when this happened, and his behavior after the episode was completely normal. Devin shook his head. "I wasn't asking anybody anything. I was alone." "Which means we can't rule it out entirely," Maggie said. "But it's not a clean fit." The canyon was fully dark now. No moon yet. The stars were sharp overhead between the canyon rims, and the creek made a constant soft sound that was the only movement in the air. I listened beyond it, out of habit. Canyons carry sound in peculiar ways. A rockfall a quarter-mile away can sound like it's right behind you. An animal moving through dry brush on the rim can sound like it's at creek level. I heard nothing unusual. Crickets. A faint rustle of something small, a mouse or a ringtail, in the leaf litter near the far edge of camp. Maggie checked her CO2 sensors before we turned in. She showed me the readings on the data logger's small screen. The ground-level sensor had crept up slightly since sunset from 410 parts per million to 430, still well within normal atmospheric range. Nowhere near the roughly 40,000 parts per million threshold where you'd expect cognitive symptoms. But the trend was there. The canyon bottom was accumulating CO2, faster than the ambient air above it. "If there are sections upstream where the canyon narrows further and the airflow drops to near zero," Maggie said, "those numbers could look very different." We agreed on a watch rotation. Not because we expected trouble, but because standard backcountry protocol in bear and lion country calls for someone being alert during the night, and because Corinne had asked us to maintain overnight observation as part of the survey. Devin took first watch, midnight to 2. I took 2 to 4. Maggie would cover 4 to 6. I went to my tent at 9:30 and fell asleep within minutes. The hiking had been moderate, but the heat and the altitude we were at, roughly 6,200 feet, had taken more out of me than I expected. I slept deeply and without dreaming until Devin's hand on my shoulder woke me at 2. "All quiet," he said. His voice was steady but low. "I heard a great horned owl around 12:30 upstream. Nothing else." I thanked him and took my position on a flat rock near the center of camp, where I could see the creek in both directions and the dark outlines of the canyon walls above. The night was still. The temperature had dropped into the mid-50s. I pulled on a fleece jacket and settled in. The first hour passed without incident. I occupied myself the way I always had on overnight watches, slow, systematic scans of the environment, listening for anything that broke the pattern of natural sound, monitoring the sky for weather changes, occasionally checking the luminous dial of my watch. The stars moved incrementally overhead. The creek ran. The darkness in the canyon was thick and textured, the kind where you can see shapes but can't verify them, where a boulder and a bear would look identical until one of them moved. At 3:10, something changed. I didn't hear it at first. I felt it, or rather, I noticed its absence. The creek was still running. I could see the faint shimmer of moving water, but the ambient sound had thinned. The crickets had stopped, not tapered off gradually the way they do when temperatures drop below their activity threshold. They stopped at once, in the middle of a chorus, as though someone had pressed a button. I sat completely still and listened. The creek, my own breathing, nothing else. Silence in the wilderness is not unusual in itself. Predator presence will shut down insect and small animal activity in a wide radius. A mountain lion moving through the drainage could produce exactly this effect. I scanned the visible ground slowly, looking for eyeshine, the reflective glow you get when a light source, even starlight, hits a predator's tapetum lucidum. I saw nothing. I considered switching on my headlamp to sweep the area, but decided against it. If there was a large predator nearby, the light might provoke a reaction, and I wanted to observe natural behavior first. The silence lasted approximately 4 minutes. Then the crickets resumed. Not gradually, simultaneously, as if the same switch had been flipped back. The chorus picked up at what seemed like the same intensity and rhythm it had been running before the interruption. I noted the time and the duration. I noted the air temperature 54 degrees. I noted the wind completely still. I noted that I had detected no visual, auditory, or olfactory evidence of wildlife during the silent interval. I noted one additional thing that I did not fully process until much later. During those 4 minutes of silence, the creek had sounded different. Not louder, not softer. The pitch had shifted. The water was making a lower sound, as though it had deepened or slowed. And when the crickets returned, the creek sound returned to normal. I told myself that was perceptual, that the absence of insect noise had changed the acoustic context and made the water sound different by contrast. That was the reasonable explanation. I finished my watch at 4 and woke Maggie. I told her about the silence event. She listened carefully, asked about the duration and conditions, and nodded. Predator transit is the obvious explanation, she said. But I'll check the CO2 readings in the morning. A sudden gas release from a geothermal vent could theoretically displace oxygen at ground level fast enough to kill insect activity in a radius. It would also be denser than air and could affect the acoustic properties of the creek by changing the gas composition of the air above the water surface. That was a better explanation than mine. I went back to my tent. I did not sleep immediately. I lay in my bag and listened to the canyon and tried to convince myself that Maggie's geothermal theory covered everything I had observed. It almost did. The silence, the insect cessation, the change in the water's sound, all of it could fit a transient CO2 release. What it didn't explain was the simultaneity. A gas plume spreading from a point source would reach different parts of the canyon at different times, depending on distance and air current. The crickets would have fallen silent progressively, starting nearest the source and radiating outward. They didn't. They stopped together, as though the signal that silenced them was not chemical or physical, but something that operated at the speed of sound or faster across the entire area simultaneously. I lay there for a long time thinking about that. When dawn came, it came slowly into the canyon. The rim caught light at 5:50, but the creek bottom stayed in shadow until after 7. I was up by 6, and Maggie already had her sensors out and was downloading overnight data with a focus I recognized as excitement. She was trying to keep professional. "Come look at this," she said. The CO2 data from the ground-level sensors showed a clear spike at 3:08 a.m., 2 minutes before I had noticed the silence. The reading jumped from 435 parts per million to 1,120 parts per million in under 90 seconds. Held at that elevated level for roughly 3.5 minutes, then dropped back to baseline over the next 2 minutes. The waist height sensor showed a smaller spike up to 680 parts per million on a slight delay. The 6-foot sensor showed almost no change. "There it is," Maggie said. "A ground-level CO2 pulse. Classic geothermal venting pattern. The gas is dense, it hugs the terrain, and it dissipates as it mixes with ambient air at higher elevations. She was almost smiling. 1,100 parts per million is not dangerous to humans. You wouldn't feel a thing at that concentration. But insects are far more sensitive to oxygen displacement. A sudden shift like that could absolutely shut down cricket activity across a campsite-sized area. "And the creek sound?" I asked. CO2 has different acoustic properties than normal air. A layer of concentrated carbon dioxide over the water surface would change how sound propagates from the creek to your ears. Lower apparent pitch is exactly what you'd predict. I nodded. It was clean. It was elegant. It was supported by data. Maggie had, in the first 12 hours of fieldwork, produced a plausible physical explanation for at least one of the phenomena reported in the drainage. Devin emerged from his tent, and Maggie explained the findings to him. He listened, nodded, and said, "That covers the campsite stuff. What about up canyon?" Maggie's expression didn't change, but her answer was careful. "That's what the next 3 days are for." We ate breakfast, broke down what we didn't need to carry, and prepared for our first full survey day upstream. The plan was to hike from base camp to waypoint R9, approximately 4 miles, taking air quality and magnetic readings at every waypoint, documenting trail conditions, and returning to base camp before dark. We left at 7:45. Devin led. Maggie walked second with her magnetometer and a belt-mounted air sensor. I brought up the rear with the radio, the incident file, and a growing sense that Maggie's CO2 theory, as satisfying as it was, had only answered the easiest question we were carrying. The canyon narrowed with every mile upstream. The first mile above base camp held to the same character we'd already seen: dark, tough walls maybe 70 feet high. The creek running clear over volcanic gravel, scattered ponderosas finding purchase wherever they could. Maggie took readings at waypoint R5, and again at a midpoint she selected between R5 and R6, where the canyon bent sharply west and the walls pinched close enough that we could touch both sides simultaneously. Her magnetometer showed baseline values. CO2 levels were ambient. She recorded everything in a weatherproof field notebook with the same small, precise handwriting she applied to everything. Devin kept up a running trail assessment, noting washouts, fallen timber across the path, sections where the creek had shifted and eroded the bank trail formerly occupied. He photographed each issue and flagged 2 spots where the trail had become genuinely hazardous. A 3-foot section where the bank had undercut and would collapse under any real weight, and a rock scramble where winter ice had loosened a slab that now sat at an angle that invited ankle injuries. He was thorough and unhurried. Whatever had happened to him between R7 and R9 in May, it hadn't made him reluctant. He moved through the drainage like someone who belonged there but was paying closer attention than he used to. At waypoint R6, a little over 1.5 miles above base camp, the canyon opened briefly into a small alcove on the eastern side, where an old rock fall had created a talus slope that climbed partway up the wall. The debris was ancient, the rocks were rounded at the edges and colonized by lichen, and at the base of the slope, partially buried in gravel, I noticed something that made me stop. A piece of milled lumber, maybe 18 inches long, 4 inches wide, weathered gray and splintered at both ends. It was clearly old decades at minimum, and it was the only piece of worked wood I'd seen in the drainage. "Mining remnant," Devin said without much interest. There were small silver and copper operations all through this country in the late 1800s. You find timbers, nails, pieces of equipment. The forest archaeologist has most of them cataloged. "This one cataloged?" I asked. He looked at it more carefully and shrugged. "Probably. There's supposed to be a mine at it somewhere up the side drainage near R7. Never been up there myself. I made a note of it, and we moved on. But I kept the lumber's location in mind. One of the details in Corinne's incident file that hadn't received much attention was a brief mention in the thru-hiker's debriefing. When asked whether he had noticed anything unusual before the onset of his disorientation, he had said almost as an aside that he had passed what looked like old mine workings and had smelled something metallic. The debriefer hadn't followed up. The comment sat alone in the transcript, unconnected to anything. The canyon continued to narrow as we approached R7. The walls here were noticeably darker, almost black in places where the volcanic tuff gave way to denser basaltic rock. The creek made sharper sounds against the harder stone. The ponderosas thinned and the vegetation along the banks became sparse, a few tenacious willows, some bunch grass, patches of moss on the shaded north-facing wall. The trail, such as it was, became less a constructed path and more a route of least resistance along the creek's edge. Maggie stopped twice in this stretch to take extended magnetometer readings. The first time, at a point roughly halfway between R6 and R7, she stood still for nearly a minute, adjusted the instrument, and took the reading again. "Getting some variance," she said. "Nothing dramatic. But the background field strength jumped about 15% in the last 100 meters, consistent with higher magnetite content in the rock." "Enough to affect a compass?" I asked. "At this level, no. A standard compass would still read true. But if there's a localized concentration of vein or deposit, you could see deviations of a few degrees in the immediate vicinity, maybe more." We reached the R7 cairn at 9:50. It was exactly as Devin had described it, a well-built stack of flat stones on the left bank, about the 3 feet tall, with an aluminum waypoint tag secured to the top stone by a wire loop. The cairn marked the junction where the unnamed side drainage entered Redstone Creek from the northeast. The side drainage was smaller and steeper, its mouth a narrow cleft in the dark canyon wall maybe 12 feet wide. And from where we stood I could see it climbed sharply and curved out of sight within 50 yards. Devin stopped at the cairn and looked upstream along Redstone Creek. The main canyon continued northeast, narrowing further. The walls were close to vertical here, and I estimated their height at 80 feet or more. Very little direct sunlight reached the creek bottom. The air was noticeably cooler, not the gradual cooling of a shaded canyon, but a distinct temperature break, as though we had crossed a threshold. I guessed the difference at 8 or 9 degrees from where we had been 15 minutes earlier. Maggie felt it too. She checked the thermometer on her pack strap. 61 degrees, she said. It was 74 at R6. "Thermal inversion," Devin said. "The narrow sections trap cold air at night, and it doesn't fully clear until afternoon. Sometimes later, depending on the wind." "Or venting," Maggie said. She was already kneeling at the creek edge with her CO2 sensor. She held it at water level for 30 seconds, then slowly raised it to chest height. Ambient at the top, slightly elevated at the bottom, 620 parts per million at creek level. Not alarming, but it's the highest reading I've taken in the field outside of a known vent. She straightened up and scanned the canyon walls. There could be a fissure vent somewhere in this section, maybe inside that side drainage. Volcanic tuff is full of fractures, and the geothermal gradient is obviously active here. You can feel the temperature differential. I was listening to Maggie, but I was watching Devin. He stood at the cairn with one hand resting on the top stone, looking upstream the way someone looks down a hallway they've walked before and found longer than it should have been. His expression was controlled, but his stillness was the kind that comes from managing something internal. "Devin," I said, "talk me through it." He understood what I was asking. The cairn was right here, he said. I stopped, checked my watch. 11:40. The weather was clear, maybe a little warmer than today. I remember the side drainage being on my left. I remember looking into it and thinking it was dark in there. And I remember thinking I should keep moving because I wanted to make R9 before noon. He paused. And then I was looking at a section of trail I recognized from a previous trip, past the big rock fall that marks R9. And my watch said 12:22. And I had this sensation, not confusion, not dizziness, more like the feeling you get when you walk into a room and forget why you went there. Except it was 42 minutes and 2 miles of canyon instead of a room. Maggie had set down her sensor and was listening with full attention. You said you looked into the side drainage and thought it was dark. Dark how? Like shade? Or dark as in poor visibility? Devin considered this. I mean, it was dim. The canyon is narrow and the walls are high. But now that you ask, I don't think I could see more than about 20 feet into it. Which doesn't make sense because the sun would have been higher at 11:40 than it is right now. And right now, I can see at least 50 yards in. We all looked at the side drainage entrance. At 10 in the morning, with the sun still climbing, visibility into the cleft was limited, but reasonable. I could see the rocky floor, the shallow trickle of water seeping from somewhere inside, and the curve where the drainage bent out of sight. Nothing about it appeared abnormal. It was just a narrow cut in the volcanic rock, one of dozens in the broader canyon system. Maggie walked to the entrance and held her magnetometer at arm's length, sweeping it slowly across the opening. Now that's interesting, she said. Her voice had changed, not alarm, professional attention. The kind of shift you hear when a person in any technical field encounters data that doesn't match their expectations. I joined her. She showed me the magnetometer's display. The reading at the side drainage entrance was nearly 3 times the background value she had been recording in the main canyon. Magnetite deposit? I asked. Maybe, but the gradient is steep. I was getting normal readings 10 meters back. This kind of jump over this short a distance that's unusual even for volcanic terrain. She took 3 steps into the side drainage, holding the instrument ahead of her. It's climbing, significantly. How high would it need to go to affect navigation equipment? I asked. Depends on the equipment. A magnetic compass could start showing deviation at field strengths, maybe 50% above background. GPS is satellite-based, so the magnetic field shouldn't affect position accuracy. But the cognitive effects of strong magnetic fields on the human brain are documented. Transcranial magnetic stimulation operates on the same principle focused magnetic fields influencing neural activity. The field strengths used in TMS are vastly higher than anything natural. But there's peer-reviewed work suggesting that prolonged exposure to anomalous geomagnetic conditions can produce perceptual disturbances in sensitive individuals. She was talking faster now, the way scientists do when a hypothesis starts finding its legs. If there's a concentrated magnetite body up this drainage, a big one, and if Devin's route took him close enough to its field of influence, it could theoretically account for the perceptual disturbance. The amnesia is harder to explain geomagnetically, but altered states of consciousness under magnetic influence are not without precedent in the literature. Devin listened to this with the particular expression of someone being told that the strange thing that happened to them might have a name and a mechanism. Relief and skepticism in equal measure. I didn't go up the side drainage, he said. I stayed on the main trail along Redstone Creek. The field could extend into the main canyon depending on the size and depth of the deposit, Maggie said. I'd need readings from multiple points to map the extent. But this is the first hard anomaly I've found. We spent 40 minutes at the R7 junction. Maggie took readings at 5-meter intervals across the mouth of the side drainage and for 20 meters in each direction along the main canyon. She plotted them in her notebook and showed us the result. The magnetic field formed a rough gradient with its highest values centered on the side drainage and dropping off in both directions along Redstone Creek. But the fall-off was asymmetric. Upstream toward R8 and R9, the elevated readings extended further than downstream. As though the source, whatever it was oriented along the axis of the side drainage, but tilted slightly toward the northeast. "This is genuinely unusual," Maggie said. "I want to go up the side drainage." I looked at Devin. He looked at the cleft in the rock. "The mine workings Devin mentioned," I said. "If there was a mining operation up there, they might have been following a magnetite vein. That could explain the concentration." "It could," Maggie agreed. "And it would also explain why the miners were there in the first place. Magnetite is associated with certain silver and copper ore bodies. If they were extracting ore from a vein, the exposed rock faces inside the mine could produce even stronger field effects than what I'm reading at the surface." "Do we have any information on the mine?" I asked Devin. "Just what the archaeologist's inventory says. Small prospect, probably 1880s or 1890s. One adit, depth unknown. Status listed as inactive and unsecured. There's no trail up the side drainage, and it's not on the maintained inventory. I don't think anyone from the district has been up there in years." I made a decision based on priorities. Our primary objective was the Redstone Creek survey from R5 to R11. The side drainage and whatever mine workings it contained were outside that scope. But Maggie's magnetic readings represented the first concrete physical evidence that something geologically unusual was happening in the R7 area. And the correlation with Devin's episode was strong enough to warrant investigation. "We continue upstream to R9 today as planned," I said. "We document the main canyon, take your readings, complete the trail assessment. Tomorrow morning, if conditions are good, we explore the side drainage." Maggie nodded without argument. Devin did too, though I noticed he did not look at the side drainage entrance again as we packed up and continued upstream along Redstone Creek. The stretch between R7 and R9 was the narrowest section of canyon we had encountered. The walls closed to within 15 feet of each other in places, and the creek occupied most of the available floor space, forcing us to wade through ankle to shin-deep water for long stretches rather than walk the bank. The rock here was uniformly dark dense, fine-grained, almost glassy in places where the canyon wall had fractured cleanly. The light was perpetual shade. Even at mid-morning, the sun was still below the angle needed to penetrate the slot. Maggie took readings continuously, pausing every 50 meters or so to log data. The magnetic field remained elevated throughout the stretch, but fluctuated in a pattern she described as irregular spikes and dips that didn't correspond to any visible feature of the rock. The CO2 readings climbed steadily. At the narrowest point of the canyon, roughly halfway between R7 and R8, the ground-level sensor showed 890 parts per million. Still not dangerous, but the trend was clear. "The air exchange in here is almost nil," Maggie said. She was speaking more quietly now, and I realized it was because the canyon acoustics had changed. Our voices sounded close and flat, without the natural echo you'd expect from rock walls. The sound was being absorbed rather than reflected. I attributed this to the rough texture of the tuff, which was heavily pitted and eroded into small cavities, natural sound dampening. But the effect was unsettling. It made the canyon feel smaller than it was, and it made silence feel like a physical substance rather than the absence of noise. Devon's pace had not changed, but his documentation had become minimal. He was still noting trail conditions, but his photographs were fewer and his written notes shorter. When I caught up to him at a point where the creek made a sharp bend around a house-sized boulder, he was standing very still with his camera lowered, looking at the canyon wall. "What is it?" I asked. He pointed. On the wall, at roughly chest height, there was a mark. Not a petroglyph. I'd seen enough Mimbres and Mogollon rock art in the region to recognize the difference. This was a series of parallel vertical scratches in the rock surface. 5 of them, each roughly 8 inches long and evenly spaced about an inch apart. They were cut into the dark basalt to a depth of maybe 1/8 of an inch, exposing lighter rock beneath. "Bear," I said automatically. Black bears will rake their claws down trees and occasionally rock faces to mark territory or simply to maintain claw condition. 5 parallel marks at that height and spacing were consistent with a large black bear standing on its hind legs. "Look at the depth," Devon said, "and the consistency." I looked more carefully. Bear claw marks on rock are typically shallow and irregular. The claws skip and chatter across the hard surface, producing uneven grooves of varying depth. These marks were uniform. Same depth along their entire length. Same spacing, same starting and ending points, as though all 5 had been drawn simultaneously with identical pressure from top to bottom. "Bear on softer rock?" I suggested. "The tuff in some of these canyons is barely harder than sandite." Devon ran his fingernail across the wall adjacent to the marks. His nail didn't leave a trace. "This isn't soft. Feel it." I did. The rock was hard. Not granite hard, but far too dense for claw marks of that uniformity and depth without significant force. Maggie joined us and examined the marks. She produced a small hand lens from her vest pocket and studied them closely. "These aren't recent," she said. "The exposed surfaces inside the grooves show the same degree of weathering as the surrounding rock face. I'd estimate these are years old, at minimum. Possibly much older." She straightened up. "They look tool-made to me. Even spacing, consistent depth, uniform termination points. Someone did this with a chisel or a multi-pointed tool." "Mining marks?" Devon asked. "Possible. Prospectors sometimes scored rock faces to test hardness or to mark locations. But these don't match any standard prospecting notation I'm familiar with." She photographed them from several angles and noted the GPS coordinates. "I'll add it to the record." We moved on. I found myself watching the canyon walls more carefully after that. Over the next quarter mile, I spotted 2 more sets of identical marks. Same 5 parallel vertical lines, same depth, same spacing. One set was at knee height on the right wall. The other was nearly 8 feet up on the left wall, well above comfortable human reaching height without a step or a ladder. All 3 sets were oriented the same way, perfectly vertical, plumb line straight, with no variation in the angle of any individual scratch within the group. I pointed out the high set to Maggie. She looked at it for a long time. "That placement is inconsistent with either bear activity or casual prospector marking," she said. "Someone would have needed to stand on something to reach that, and there's nothing nearby they could have used. The creek bottom is flat here." "Could the creek level have been higher in the past?" Devon asked. "If there was more gravel buildup, the floor could have been 2 or 3 feet higher." "Possible," Maggie said. She didn't sound convinced. We reached waypoint R8 at 11:20. The waypoint was marked by a smaller cairn than R7, partially collapsed, with its aluminum tag bent but still legible. The canyon here was at its narrowest. I estimated the walls were no more than 12 feet apart, and the creek filled the bottom from wall to wall in a shallow sheet of water that moved slowly over flat rock. There was no dry ground. We stood in the creek to take our readings. Maggie's magnetometer showed the highest values yet. She checked the instrument twice, recalibrated it once, and took the reading a third time. "This is more than magnetite in the rock," she said. "I'm getting field strength that suggests a concentrated subsurface body, something large and dense, probably within 50 meters of where we're standing, either below us or inside the canyon wall." She looked up at the dark rock rising above us on both sides. There could be a massive magnetite deposit running through this section. If the mine workings in the side drainage were targeting the same formation, it might extend this far. "What does that mean for what Devon experienced?" I asked. Maggie chose her words carefully. "At the field strengths I'm measuring now, which are roughly 5 to 6 times normal background, the scientific literature would suggest possible subtle effects on vestibular function and spatial processing in susceptible individuals during prolonged exposure. The vestibular system, your inner ear's balance and orientation mechanism, is sensitive to magnetic fields. There are studies showing that strong static magnetic fields can induce a mild sensation of spatial disorientation. Most subjects describe it as a feeling that the world has shifted slightly, or that their sense of direction is unreliable." She let that sit for a moment. "But I want to be clear," she continued. "The field strengths in those studies are orders of magnitude higher than what I'm measuring here. We're talking about MRI-level fields, not geological ones. What I'm seeing is anomalous for a natural setting, absolutely. But it shouldn't be strong enough to produce the kind of effects Devon described, certainly not a 42-minute memory gap." "Shouldn't be," Devon repeated. "Based on current understanding," Maggie said. "Which is exactly why I'm here. If there's something about the specific combination of factors, the magnetic anomaly, the CO2 concentration, the canyon geometry, the thermal conditions that produces effects beyond what any single factor would predict, that's a legitimate finding." We continued upstream. The canyon widened slightly above R8. And by mid-afternoon we had reached R9 without incident. The waypoint was marked by a significant rockfall, a section of the east wall that had collapsed at some point, creating a field of large boulders that the creek had to find its way through. The aluminum tag was fixed to a boulder at the upstream edge of the debris field. Devon stood next to it and looked back downstream. Toward the 2 miles he didn't remember. "It was right here," he said quietly. "This is where I came back." The phrase struck me, not where I snapped out of it or where I realized what happened. Where I came back. As though some part of him understood that he had been somewhere else during those 42 minutes, even if his body had been walking this canyon the entire time. We ate lunch sitting on the rockfall boulders. The sun had finally penetrated deep enough into the canyon to reach us, and the warmth was welcome after hours in the cold shade. Maggie organized her data while she ate, plotting the magnetic readings on a cross-section diagram of the canyon. The pattern was clear, even in rough sketch form. Field strength rose approaching R7, peaked between R7 and R8 with the highest values centered near R8, and began declining above R8 toward R9. The anomaly was roughly centered on the narrowest, deepest section of the canyon, which was also where the side drainage intersected. "Whatever the source is," Maggie said, tapping her pencil on the R8 area of her sketch, "it's in here. And the side drainage is the most accessible path to it." The radio check at noon went smoothly. I raised Corinne on the second call and gave her our position and a summary of Maggie's findings. Corinne listened without interrupting, then asked one question. "Has anyone on the team experienced any perceptual disturbance?" I looked at Devon. He shook his head. I looked at Maggie. She shook her head. "Negative," I said. All three of us are functioning normally. Copy, Corinne said. Continue as planned. If anyone reports symptoms, I want immediate notification, and I want you moving back to base camp. Don't investigate through impairment. It was a good order, clear, conservative, and professional. I acknowledged it and signed off. We began the return hike at 1 o'clock. The downstream walk was easier. We were moving with a slight grade rather than against it, and we made better time. Devin loosened up as we put distance between ourselves and the R7 to R9 corridor. And by the time we were approaching R6, he was talking about the seasonal patterns of the drainage, the way the creek could triple in volume during a good monsoon storm, the flash flood risk in the narrower sections. Maggie walked with her magnetometer running, collecting data on the return pass to compare with her upstream readings. She confirmed that the gradient was symmetric. The anomaly peaked in the same location from both directions. We were within a half-mile of base camp, just past R5, when Devin stopped on the trail ahead of me and crouched down. Ashcroft, come look at this. I moved up beside him. He was pointing at the trail surface, packed dirt and gravel between the creek bank and the canyon wall. There was a footprint, not a boot print. The trail was used regularly enough by hikers that boot impressions were common and unremarkable. This was a bare human footprint. Right foot. Clear toe impressions, ball of the foot, and a partial heel. The person who made it had been walking upstream toward R7, and the print was fresh. The edges were sharp, and the displaced gravel hadn't been rained on or windblown. In this sheltered canyon, with no significant wind, a print this clean could last days. But the moisture in the soil where the toes had pressed was still dark. Hours old, not days. We didn't pass anyone on the trail today, Devin said. We hadn't. The trail from the Middle Fork Junction to this point had been empty. No other hikers, no other rangers, no footprints heading upstream that we had noticed on our way in that morning. Could have come from the Middle Fork Trail and turned up after we passed this point heading upstream, I said. We left base camp at 7:45. Anyone coming up after 8 and hiking at a reasonable pace would have reached here by mid-morning. Barefoot? Devin said. That was the problem. Recreational hikers in the Gila did occasionally wade barefoot in the creek or around camp, but nobody hiked the canyon trail barefoot. The terrain was too rough, volcanic gravel, sharp rock edges, cactus debris. Walking this trail without boots would be painful and risky. I knelt and examined the print more carefully. It was a large foot, I estimated roughly a size 11 or 12. The impression was deep, suggesting a heavy person or someone moving with force. The stride pattern, based on the single print and the disturbed gravel ahead and behind it, suggested a normal walking pace. I looked upstream along the trail for additional prints, but the surface changed to exposed rock within a few yards, which wouldn't hold impressions. Mark it, I said. Devin flagged the location with a piece of orange ribbon tied to a willow branch. I photographed it with my camera and noted the GPS coordinates. When we got back to base camp, I checked the perimeter. Our tents and equipment were undisturbed. The food hung was intact. There was no sign that anyone had visited the camp in our absence. Maggie's sensors, which she had left running at the campsite, showed unremarkable data for the entire day. But there was one thing. The ground-level CO2 sensor, the one she had placed closest to the creek at the campsite, had been moved. Not much. Maybe 8 inches to the left of where she had placed it. The sensor was sitting on a flat rock she had selected specifically because it was stable and level. And it was now sitting on the gravel beside the rock, tipped at a slight angle. "Are you sure that's not where you put it?" I asked. Maggie looked at the sensor, then at the rock. I'm sure. I placed it dead center on that rock because I needed it level for accurate readings. It's not on the rock now. Wind? The sensor weighs almost 2 pounds, and it was stable on a flat surface. There hasn't been enough wind today to move a paper cup. Animal? Possible. A bear investigating camp could have nudged it, but there's no other sign of animal disturbance. The food hang is untouched. There are no tracks. I did a thorough scan of the campsite ground. The gravel didn't hold prints well, but in the softer soil near the creek bank, I found nothing. No bear tracks, no boot prints, no barefoot impressions. Whatever had moved the sensor hadn't left traces on the surrounding surface or hadn't approached from the creek side. Devin stood at the edge of camp looking upstream toward R7 with an expression I couldn't read. Someone's in the drainage, he said. Maybe, I said. One footprint and a moved sensor doesn't confirm that. Someone is in the drainage, he said again. And this time, it wasn't a hypothesis. It was the voice of a person who has spent enough time in a place to know when the place has changed. I reported the footprint and the moved sensor to Corinne at the 5 o'clock radio check. She copied the information and asked whether we wanted extraction. Negative, I said. We're secure and the evidence doesn't indicate a threat. But I'd like you to check whether any permits were issued for this drainage in the last 48 hours. I'll check tonight, she said. Be aware that unpermitted use is common in the Gila wilderness. We average 6 to 8 contacts per month with hikers who didn't register. She was right. The Gila was vast, and the permitting system was voluntary. It was entirely possible that an unregistered hiker had entered the drainage after us, walked upstream, and was now camped somewhere between our position and R7. The barefoot print was unusual, but not inexplicable. Maybe they had been wading in the creek and stepped onto the trail momentarily. Maybe they were an eccentric. The backcountry attracts all types, but the moved sensor bothered me in a way the footprint didn't. The footprint was physical evidence of a person walking through. The sensor was physical evidence of a person or something interacting with our camp while we were away. Those are different categories. One is passage, the other is presence. That night, after dinner, Maggie set up her sensors with particular care. She placed the ground-level CO2 monitor back on the flat rock, but this time, she used a small piece of adhesive tape on the bottom to mark its exact position relative to a scratch she made on the rock's surface. If it moved again, she would know exactly how far and in which direction. Devin took first watch again. Maggie and I stayed up later than the previous night, talking through the data. She was genuinely engaged now the magnetic anomaly had given her professional purpose, and the prospect of exploring the side drainage the next morning had her making lists of measurements she wanted to take. But beneath the scientific excitement, I could sense something else. A careful awareness that her data, while interesting, was accumulating faster than her explanations. The magnetic field at R8, she said. I keep running the numbers, and it's higher than it should be, even for a concentrated magnetite body. I've worked on magnetite deposits in the Jemez Mountains and in the Black Range, and the surface field expressions from those were maybe twice background. What I measured today was 5 to 6 times. That either means the deposit here is unusually large and unusually close to the surface, or there's something about the geometry of the canyon that's focusing the field in a way I'm not accounting for. Or your instrument is off, I said, not unkindly. She gave me a look that was half smile, half challenge. I calibrated it this morning against a known reference. The instrument is fine. She paused. I know what you're thinking. You're thinking the data is convenient. Magnetic anomaly in the same location as the weird experiences. Too neat. The thought crossed my mind. Fair. But that's how geology works sometimes. The unusual experiences brought us here, and the unusual geology was already here. The correlation might be causal, or it might not. But the data is real. Those readings are what the rock is producing. I didn't put them there. I believed her. Maggie was not the type to shade data toward a preferred conclusion. She was rigorous in the way that distinguishes a career scientist from a person with a theory looking for confirmation. I turned in at 10. The canyon was quiet, except for the creek and the insects. The stars were thick overhead, and I could see the faint glow of the Milky Way spanning the narrow gap between the canyon rims. I fell asleep thinking about the footprint, about the way a bare foot presses into volcanic gravel and leaves an impression of someone walking toward the center of something they should probably be walking away from. Devin woke me at 2. "Quiet night," he said. "No sound events. Maggie's sensor hasn't moved." I took my position on the flat rock and settled into the watch. The routine of it was familiar, the slow visual sweeps, the listening, the patient attention to an environment that reveals itself differently in darkness. The canyon was cool again. 52 degrees. The creek ran silver in the starlight. At 2:35, I heard something. Not the sudden silence of the previous night. The opposite. A sound that shouldn't have been there, coming from upstream. It was rhythmic, steady. A soft, percussive impact repeated at intervals of roughly 2 seconds. I listened for a full minute before attempting to characterize it. The sound was similar to, but not exactly, a person walking in the creek. Footsteps in shallow water produce a complex sound. The splash, the gravel displacement, the settling. What I was hearing had the rhythm of footsteps, but the tonal quality was wrong. There was no splash, no water displacement sound. Just a clean, dry impact, evenly spaced, growing neither louder nor quieter. Constant distance, constant volume. As though the source was moving but not approaching or receding. Moving laterally, perhaps, or circling at a fixed distance upstream. I reached for my headlamp but didn't turn it on. I wanted to keep my night-adjusted vision, and I wanted to listen without the psychological distraction of a light beam, creating a small circle of visibility that would make everything outside it seem darker by contrast. The sound continued for approximately 3 minutes. Then it changed. The rhythm doubled 2 impacts in quick succession, then a pause, then 2 more, like a person who had been walking and was now taking pairs of quick steps with rests between. This pattern held for maybe 30 seconds. Then it stopped. The silence after was complete. Even the creek seemed quieter, though I knew that was subjective. I sat motionless for another 10 minutes, listening. Nothing resumed. The insects continued without interruption. No silence event. No behavioral change in the ambient environment at all. At 4, I woke Maggie and described what I had heard. She listened with her characteristic focus, asked about the distance, the duration, the acoustic quality. "How far upstream?" she asked. "Hard to judge in a canyon. Sound reflects off the walls and distorts distance perception. My best estimate is 200 to 300 yards. That's in the general direction of R7. "Yes." "And the doubled rhythm, you're certain it changed from single to paired impacts?" "I am." She thought for a moment. Geothermal venting can produce rhythmic sounds. Fumaroles sometimes pulse as pressure builds and releases in subsurface chambers. A regular interval like what you described isn't inconsistent with that. The change in pattern could indicate a shift in venting dynamics, a partial blockage clearing, or 2 vents alternating. "At 2-second intervals?" I said. "That's a very fast cycle for geothermal activity." "Agreed. It's at the edge of plausible. but I don't want to rule it out without data. She glanced upstream into the darkness. Tomorrow. The side drainage. That's where the answers are. I didn't sleep after my watch. I sat in my tent with the flap open, facing upstream, and waited for dawn. Not because I was frightened. Because I was doing what 30 years in the backcountry had taught me to do when the evidence starts accumulating faster than the explanations. I was paying attention. Cataloging. Building the picture. And the picture that was forming had pieces that fit together and pieces that didn't. And the pieces that didn't were all pointing in the same direction. Upstream. Into the side drainage. Into the dark rock. When the light came, I checked Maggie's ground-level sensor. It was exactly where she had placed it. The tape mark aligned perfectly with the scratch on the rock. Nothing had moved it. But something else was different. I noticed it while making coffee, standing at the cook area, looking across the campsite in the early gray light. Devon's tent was fine. Maggie's tent was fine. The food hang was undisturbed. Everything was in its proper place, except the cairn. Waypoint R5, 30 yards downstream from camp, the small stack of stones marking the trail. It had been 4 stones high when we arrived. I had noted it specifically during my baseline inventory of the campsite. It was 5 stones high now. The additional stone was flat, roughly 6 inches in diameter, and had been placed neatly on top of the existing stack. It matched the dark volcanic rock of the canyon walls. Its placement was precise, centered, level, aligned with the stones beneath it. I walked to the cairn and examined it without touching the new stone. The existing stones showed lichen growth and weathering, consistent with years of exposure. The new stone on top was clean. No lichen. The surface where it contacted the stone beneath it was dry, meaning it had been placed after the morning dew would have collected on the existing stones sometime in the last hour, or sometime during the night before dew formed. Devon and Maggie had been in their tents. I had been on watch from 2 to 4, facing upstream, with the cairn behind me and 30 yards downstream at the limit of my night vision. Maggie had been on watch from 4 to 6, but the cairn was on the trail below camp and might have been outside her attention zone, depending on where she positioned herself. I called them both over. Devon looked at the cairn and counted the stones. "That wasn't there yesterday," he said. Maggie studied it with her hand lens. "The placement is deliberate. This wasn't kicked up by an animal or dropped by a bird. Someone set this stone on the stack." "During the night," I said, "while we were here." The 3 of us stood looking at the cairn in the quiet of the canyon morning. And nobody said anything for a long time, because nobody had an explanation that fit comfortably inside the professional frameworks we had carried into this drainage. Someone or something was in Redstone Creek Canyon with us. It moved without leaving tracks. It had passed through or near our camp at least twice. It had interacted with our equipment and with an established trail marker, and it had done all of this within a few hundred yards of 3 experienced wilderness professionals, one of whom was awake and watching at all times, without being seen. Maggie broke the silence first. "We go up the side drainage today. Whatever is happening in this canyon, the geology is the thread we can follow. If there are mine workings up there, if there's a vent system, if there's a magnetite body large enough to explain these readings, that gives us a framework. Everything else is observation without mechanism." Devon looked at me. He was waiting for my decision, not because he lacked the experience to make his own, but because Corinne had put me in charge of this survey and he respected the structure. I waited. 3 anomalous observations in 2 nights. A barefoot print, a moved sensor, a stone added to a cairn, rhythmic sounds from upstream, elevated CO2, an unprecedented magnetic anomaly, a seasonal ranger with a 42-minute hole in his memory, and a geologist with a plausible framework that could explain some of it, maybe most of it, if the source turned out to be what she suspected. Going up the side drainage was the logical next step. It was also the step that would take us closer to whatever we were documenting. Those two facts were not in conflict. They were the same fact, viewed from different angles. "We go," I said. "Full packs. If the drainage is passable, we survey it as far as we can in a half day and return to base camp by mid-afternoon. Nobody goes more than 10 yards from the group. Nobody goes off radio. If anyone experiences any perceptual disturbance, any confusion, disorientation, memory irregularity, nausea, visual disturbance, we stop immediately and return to base camp. No exceptions." Devin and Maggie both acknowledged. We broke camp by 7:30 and hiked upstream to R7. The morning was clear. The canyon was cool in the shade and warm in the scattered patches where the sun reached the floor. The creek ran normal. The insects were active. Everything about the drainage felt ordinary in the daylight. The way a house that unsettled you at midnight seems foolish to have worried about by morning. We reached the R7 cairn at 8:45 and turned into the side drainage. The side drainage swallowed the light within 50 yards. Not completely. The sky was still visible as a bright, irregular strip far above, but the walls were close and high, and the angle of the morning sun put everything below the rim in shadow that felt more like dusk than shade. The floor was dry rock with a thin seep of water tracing the lowest point, barely enough to dampen the gravel. Our boots scraped and echoed in a way that made the space feel enclosed, almost interior, like walking into a building rather than up a canyon. Devin led. He moved carefully, testing footing on the uneven rock, pausing at each turn to assess what was ahead before committing. Maggie followed with her magnetometer held at waist height, watching the display with an intensity that suggested the readings were already telling her something. I came last, carrying the radio and scanning the walls, the floor, the narrow strip of sky above. The drainage climbed steeply. Within the first 100 yards, we gained what I estimated at 40 or 50 feet of elevation. The walls were uniformly dark, the same dense basaltic rock we had seen in the main canyon between R7 and R8. But here the surface was smoother, less weathered, as though the narrowness of the cleft had protected it from the erosion that textured the wider canyon. In several places, the rock had a faint sheen, a dull metallic luster that caught the indirect light. "Magnetite in the matrix," Maggie said, running her hand along the wall without quite touching it. "You can see it, the dark mineral with the submetallic luster. It's disseminated through the basalt, but the concentration here is higher than anything in the main canyon." She checked her magnetometer. "Field strength is climbing. We're already above what I recorded at R8 yesterday." The drainage narrowed further. At one point, we had to turn sideways to pass through a gap where the walls came within 2 feet of each other. The rock on either side was cool to the touch and perfectly dry. Beyond the gap, the drainage opened slightly into a space maybe 8 feet wide and 20 feet long, a small chamber where the walls stepped back before closing in again, upstream. The floor here was flat rock covered by a thin layer of fine sediment, dark, powdery, almost like volcanic ash. Devin stopped at the edge of this chamber and pointed at the floor. Footprints. Multiple footprints in the fine sediment running the length of the space. Bare human feet. The same proportions as the print we had found on the trail below, large, probably size 11 or 12. Deep impressions suggesting significant body weight or forceful stride. They led upstream through the chamber and into the narrowing drainage beyond. But what stopped me was not the prints themselves. It was the pattern. The footprints did not walk a straight line through the chamber. They circled. The prints traced a rough oval around the perimeter of the open space, staying within a foot or two of the walls, and the oval had been walked multiple times. The prints overlapped, newer impressions partially obscuring older ones, creating a layered record of repeated circuits. Someone had walked in circles in this small stone chamber barefoot over and over. Maggie crouched beside the nearest cluster of prints and examined them. These aren't all the same age. See how some are sharper than others? The deeper, cleaner ones are more recent. The shallower, softer ones have had time to settle. This happened over multiple visits. How many circuits? Devon asked. Maggie traced the oval carefully, counting overlapping impressions at a point where the pattern was clearest. Hard to say precisely. At least 8. Possibly more. The older passes are too degraded to distinguish individually. I studied the footprints for several minutes. The stride length was consistent throughout roughly 28 to 30 inches, which is normal for a person of average to tall height walking at a moderate pace. The depth was consistent too. No signs of stumbling, stopping, or changing speed. Whoever had walked these circles had done so steadily and evenly, lap after lap, like someone following a prescribed route. Ritual behavior? Devon asked. He said it carefully, like a person testing whether the word would be taken seriously. Maggie shook her head. I don't want to speculate about intent, but the pattern is deliberate. This isn't someone pacing randomly. The oval is consistent in shape from pass to pass. They were following the same path each time. I photographed the chamber and the prints from multiple angles, then took a wider shot, showing the chamber in context within the drainage. As I was framing the wider shot, I noticed something on the wall near the upstream exit of the chamber. Another set of the parallel scratch marks we had seen in the main canyon. 5 vertical lines, evenly spaced, consistent depth. These were at waist height on the left wall, and directly opposite them on the right wall, at the same height, was an identical set. The 2 sets faced each other across the narrow passage like marks on a door frame. Those are the same as the ones downstream, Devon said. Identical, Maggie confirmed. She measured the spacing between the scratches with a small ruler from her kit. 23 millimeters between each line. That's the same spacing I documented yesterday at the first set. Same tool, same hand, same deliberate, precise execution. Whatever had made these marks had done so consistently across multiple locations in the drainage, using the same instrument and the same technique. Maggie took an extended magnetometer reading in the chamber. Her expression shifted as she watched the display. The field in here is an order of magnitude above anything I've recorded, she said. Her voice was controlled, but the information was not. This is genuinely anomalous. The magnetite concentration in the surrounding rock must be extraordinary. I would need a proper geophysical survey to confirm, but based on these surface readings, there could be a massive ore body directly beneath us or within the walls. What does that mean for us physically? I asked. Standing here right now. At these field strengths, honestly, I'm in uncharted territory for natural geological settings. The documented effects of static magnetic fields on human physiology are mostly from medical imaging research. And those fields are generated by superconducting magnets, not rock. But there is theoretical work suggesting that sustained exposure to anomalous geomagnetic fields could influence temporal lobe activity. The temporal lobe is involved in memory formation, spatial orientation, and interestingly, the perception of presence. The feeling that someone is nearby when no one is. She let that statement settle in the stone chamber with its circling footprints and its facing scratch marks. "I'm not saying that's what's happening," she added. "I'm saying the mechanism exists in the literature as a hypothesis. And the field strengths I'm measuring here are the first natural readings I've ever seen that approach the range where those effects become theoretically plausible." Devon had been quiet through this exchange. He was standing near the upstream exit of the chamber, looking into the continuing drainage beyond. And his posture had changed. Not fearful, watchful, the way a person stands when they're listening to something they haven't mentioned yet. "Devon," I said. "I hear water," he said. "Running water. More than the seep." I listened. He was right. From somewhere upstream, beyond the next narrowing, there was the sound of flowing water. Not the thin trickle that had been following the drainage floor, but something more substantial. A creek or a spring. We continued upstream. The drainage constricted again beyond the chamber, forcing us through another sideways passage, and then opened into a section where the walls were perhaps 10 feet apart and the floor dropped into a shallow channel carved into solid rock. Water flowed through this channel, clear, cold, and surprisingly vigorous. A spring emerging from a fissure in the base of the left wall. The water was noticeably colder than Redstone Creek. When I dipped my hand in, the temperature difference was immediate and sharp. Maggie knelt and cupped some water in her hand, sniffed it, touched her tongue to it. "Mineral content is high," she said. "Strong iron taste, and cold I'd estimate low 50s. That's consistent with a deep source. Water this cold in August has been underground for a significant distance." The spring emerged from a horizontal crack in the rock about 6 inches high and 2 feet wide. The flow was steady, not pulsing, which Maggie said suggested a constant pressure source rather than a geothermal intermittent. She took a water sample in a small bottle from her kit and labeled it with the coordinates and time. Above the spring, the drainage climbed another steep section, and then it abruptly leveled out onto a shelf of rock that extended back into the canyon wall like a natural porch. And at the back of this shelf, half hidden by a rockfall that had partially collapsed across it, was the mine. The adit was small, maybe 4 feet high and 3 feet wide, a rough opening cut into the dark rock that had been enlarged from what might have been a natural crack or a small cave. The rockfall covered the lower third of the entrance, leaving a gap at the top that was large enough to crawl through but not to walk through. Timbers, the same gray, weathered wood as the piece I had found below at R6, framed the opening on both sides but not across the top. Either the header timber had fallen or it had never been installed. The rock above the opening showed drill marks, old ones, hand-drilled from the era before pneumatic equipment, the characteristic star pattern holes left by a hand-rotated steel bit. Devon and I stood looking at the mine entrance while Maggie took readings. "This is it," she said. "The field strength at this opening is the highest I've recorded, and I'm getting a slight air movement from inside. Feel it?" I held my hand near the gap above the rockfall. She was right. There was a faint but steady exhalation of air from inside the mine. Cool air, carrying a mineral smell that was more complex than the iron tang of the spring water. Something earthy and dense, with an underlying sweetness that I couldn't identify. "The mine is breathing," Maggie said. "That means it connects to a larger underground space, either natural cavities or additional excavated passages. The air differential between the interior and exterior is driving a constant low-volume exchange. And the temperature and mineral content of that air tells us the interior space is significant." "You want to go in?" I said. "I want to take readings from inside, yes. The surface measurements suggest the magnetite body is close. But the field geometry only makes sense if the source is within or beyond the mine opening. 10 meters inside could tell us more than a week of surface readings. I evaluated the situation. The mine opening was partially collapsed, but the remaining gap was passable for one person at a time. The airflow indicated the space beyond was not sealed, which reduced the risk of oxygen depletion but introduced the possibility of unstable passages. Abandoned mines are among the most dangerous environments. A person can enter bad air, unstable ceilings, hidden shafts, rotted timbers. Every ranger in the service has been briefed on the danger. Most districts have explicit policies prohibiting entry without specialized training and equipment. We don't have mine entry gear, I said. No hard hats, no gas monitors rated for confined space, no rope, no backup communication. We have a CO2 sensor, a headlamp, and 3 experienced adults, Maggie said. 2 experienced wilderness professionals and 1 geologist who studies rocks, not mines, Devin said. It was the first thing he'd said in 20 minutes, and it carried an edge that surprised me. He was looking at the mine entrance with an expression that had moved past watchfulness into something more fixed. Not exactly resistance, certainty. The certainty of someone who knew something he hadn't been asked. "Devin?" I said. He took a breath. "I don't think we should go in there." "Because of the structural risk?" Maggie asked. "Because of the sound." Maggie and I both waited. "When I was on watch last night," Devin said, "around 12:45, I heard something from this direction. Not the rhythmic sound Ashcroft described later. Earlier, different. It was a low sound, very low, almost below hearing. More like a vibration than a sound. I felt it in my chest. It lasted maybe 15 seconds and then stopped." He looked at the mine entrance. "It came from in there. I know how sound moves in this canyon. I've been working this drainage for 2 seasons. That sound came from underground." "Why didn't you mention this?" I asked. Not accusatory. I needed to understand the omission. "Because it stopped, and because I convinced myself it was a small seismic event, a micro-tremor. They happen in volcanic terrain. I felt them before at the station, and they produce a similar low-frequency sensation. I filed it and moved on." He paused. "But standing here right now, looking at this opening, I don't think that's what it was." Maggie absorbed this without visible reaction. She was quiet for a long time, looking at the mine entrance, looking at her magnetometer, looking at the gap in the rockfall where cool, mineral-scented air moved steadily outward. "A subsurface vibration is consistent with several geological phenomena," she said carefully. "Magma movement at depth, hydrothermal pressure fluctuations, even settling of rock in old mine workings. But Devin's right that we should take it seriously. If there's active geological instability in the mine, entering it becomes significantly more dangerous." I made my second major decision of the survey. "We do not enter the mine today. Maggie, take every reading you can from the entrance. Devin, I want photographs and measurements of the opening, the timbers, the drill marks, everything we can document from outside. I'll report to Corinne at our noon check and request guidance on mine entry protocol." Nobody argued. Maggie worked for over an hour at the mine entrance, taking magnetometer readings from every accessible angle, measuring CO2 and hydrogen sulfide concentrations in the air emerging from the gap, recording the air temperature differential, collecting a sample of rock from the wall immediately adjacent to the opening. Devin documented the physical characteristics of the adit with meticulous care, photographing the drill marks, measuring the timber dimensions, sketching the rockfall pattern. I stood watch, monitoring the drainage in both directions, listening for any recurrence of the sounds Devin or I had described. During this time, I noticed something I did not immediately share with the others. The flat shelf of rock outside the mine entrance, the natural porch, showed wear patterns. The surface was smoother than the surrounding rock in a specific area. A roughly oval path near the entrance, maybe 6 feet wide and 10 feet long. The same kind of wear you see on popular hiking trails where thousands of boots have polished the stone over decades. But this was in a remote side drainage that, according to Devon, no one from the district had visited in years. I knelt and looked at the worn area more carefully. The oval path matched the dimensions and shape of the circling footprints in the chamber below. Someone had been walking ovals here too. Not once, not 10 times. Often enough and long enough to wear the rock smooth. I told Maggie and Devon. Maggie examined the wear pattern and took photographs. Her expression was unreadable. Rock polish from foot traffic takes a long time to develop, she said. Years, decades. This wasn't made by a casual visitor. Someone spent a significant amount of time walking this path. A miner? Devon asked. Miners don't walk in circles outside their mine entrance. They go in, they work, they come out. They rest, they eat. They don't pace ovals. Someone else then, I said. Before the miners or after? Maggie looked at the mine entrance, at the worn rock, at the chamber below us where the footprints circled in the volcanic dust. Before, during, or after, she said. Or all three. We completed our documentation by 11:30 and began the descent back to the main canyon. The return through the side drainage was uneventful, though I noticed that none of us spoke much. The data we had collected was substantial. Maggie's instrument readings alone would take days to fully analyze, but the data existed alongside observations that resisted the same clean, analytical framework. Circling footprints, worn rock, scratch marks of inhuman consistency, a mine that breathed and hummed. At the R7 cairn, we turned downstream and hiked back to base camp. The main canyon felt open and bright after the constriction of the side drainage. And I caught myself taking deeper breaths as the walls widened around us, as though I'd been breathing shallowly without realizing it. Devon noticed. You feel it too, he said. The side drainage does something to your breathing. I thought it was just the narrow space, but it happens even when the walls aren't that close. Higher CO2 concentration, Maggie said from behind us. Your body adjusts respiration rate unconsciously when CO2 is elevated. Slightly shallower, slightly faster breathing is a normal response. You don't notice it until you return to normal atmosphere and your breathing depth changes back. Is that what it is? Devon asked. That's the measurable explanation, Maggie said, which was not the same as saying yes. We reached base camp at 1 o'clock. The first thing I did was check the campsite. Tents undisturbed, food hang intact, equipment where we had left it. Maggie's sensor on its rock, tape mark aligned. The cairn at R5 was different again. It was still 5 stones high. The new stone had not been removed. But on the flat top of the 5th stone, someone had placed a small object. I saw it from 15 feet away, a dark shape against the dark rock, small enough to fit in a palm. I approached it slowly, as I would approach any unexplained object in the field, and stopped a foot away. It was a tooth, a molar. Large, heavy-rooted, and unmistakably human. It was old, the enamel was yellowed and worn. The root darkened to a deep brown, and there was no flesh or tissue attached. It had been out of a jaw for a very long time. Decades, probably. But it was whole, undamaged, and it had been placed on the cairn with the same deliberate precision as the stone beneath it. I did not touch it. I called Devin and Maggie over. Devin looked at it and took a step back. Not dramatic, not panicked. A physical recoil that he controlled immediately but couldn't prevent. Maggie leaned in and studied it. Human molar. Looks like a lower first molar based on the root morphology. The wear pattern on the crown is significant. This was from an adult, probably middle-aged or older, with heavy occlusal wear. The discoloration and preservation suggest it's been removed from the body for a long time. There's no soft tissue, no odor of decomposition. This tooth has been dry for years. From the mine, Devin said. A miner. Someone who died up there. That's one possibility, Maggie said. Historic mine fatalities in this region aren't uncommon. But that doesn't explain how it got from the mine to our cairn. Someone brought it, I said. Someone brought it, Maggie agreed, while we were in the side drainage. I looked at the timeline. We had left base camp at 7:30, reached R7 by 8:45, spent 2.5 hours in the side drainage, and hiked back. During that entire period, the campsite was unattended. But the side drainage was the only route between the mine and our camp that didn't involve climbing out of the canyon and traversing the rim, a journey of several miles over difficult terrain. If someone had followed us up the side drainage, retrieved the tooth from the mine or its vicinity, descended ahead of us or by an alternate route, and placed it on the cairn, they would have had to do so within the window of our absence, and without leaving prints on the trail we had walked in both directions. I checked the trail surface between camp and R7. Our boot prints from the morning's upstream hike were clearly visible in the softer sections. Overlaid on them were our return prints from the downstream walk, identifiable by the reverse direction and the fresher edges. I saw no other prints, no barefoot impressions, no evidence of a fourth person walking the trail in either direction. I reported everything to Corinne at the 2 o'clock radio check. I gave her the full inventory, the footprint chamber, the scratch marks, the mine entrance, the magnetic readings, Devin's subsurface vibration, the worn rock, and the tooth. I kept my voice level and factual. Corinne listened to the entire report without interruption, which was unusual for her. She typically acknowledged each item as it came. When I finished, the radio was silent for several seconds. "Ashcroft," she said, "I need you to listen to something." "Go ahead." "I checked the permit records last night as you requested. No permits issued for the Redstone Creek drainage in the past 60 days. But I also pulled the district's historical incident file for that drainage going back 20 years. There's something in there I didn't include in the folder I gave you because I didn't think it was relevant at the time. I'm listening." In 1997, a seasonal ranger named Paul Esterhaus was assigned to do a trail survey of the Redstone corridor. Same job Devin was doing in May. Esterhaus hiked in, completed his survey to R9, and hiked out. His written report was normal. Trail conditions, water crossings, nothing unusual. But his supervisor at the time, a man named Gene Koenig, who retired before I came on, attached a handwritten note to the file. The note says that Esterhaus came into the office the day after his survey and asked Koenig whether anyone had ever reported walking sounds in the canyon at night. Koenig told him no. Esterhaus then asked whether the mine in the side drainage was on any active claim or was known to be occupied. Koenig told him no. And then Esterhaus said, and Koenig wrote this down word for word, "Something in that canyon wants you to walk in circles." The radio hissed softly. I could hear the station's background noise, a fan maybe, or the hum of the building's electrical system. Koenig noted the conversation, but didn't follow up. Corinne continued. Esterhaus finished the season and didn't return the following year. I have no contact information for him in the current system. He left the Forest Service in 1998. And no one went back up there to investigate what he reported, I asked. Not specifically. The drainage continued to be included in routine trail surveys. But the comments in Esterhaus's report and Koenig's note weren't flagged as anything requiring follow-up. They sat in the file. Until now. I asked Corinne about the mine entry question. She was unequivocal. No entry. The district does not have confined space rescue capability, and the nearest mine rescue team is in Silver City, over 2 hours out. If you need subsurface data, Maggie can take readings from the entrance, but nobody goes inside. That's a direct order, Ashcroft. Understood. One more thing. The tooth. I want it preserved. Don't handle it directly. Bag it and bring it out. I'll contact the forest archaeologist and the county sheriff's office. If it's from a historic fatality, it's an archaeological resource. If it's from something more recent, it's potential evidence. Copy. I signed off and relayed Corinne's information to Devin and Maggie. The Esterhaus account changed the complexion of the investigation in a way that was difficult to articulate precisely, but impossible to ignore. Our observations were not singular. They were not a product of our particular group dynamics, our expectations, or Maggie's instruments. 14 years before we set foot in this drainage, a ranger with no knowledge of our mission had independently reported 2 of the same phenomena, walking sounds and circular movement. And he had described the experience not as something he observed, but as something the canyon wanted. Devin took the Esterhaus account hard. Not visibly, he maintained his composure. But the muscles in his jaw worked, and he spent several minutes reorganizing gear that didn't need reorganizing. The kind of purposeless physical activity a person engages in when their mind needs time to process something the body can't help with. Maggie took it differently. She sat on a rock near the creek with her field notebook and wrote for 10 minutes straight, filling 2 full pages with dense, small text. When she finished, she looked up and said, "We need a night in the side drainage." Devin's hands stopped moving on the gear. "Not in the mine," Maggie said quickly. "At the chamber, the footprint chamber. That's the location with the clearest evidence of repeated human activity, and it's the location where my magnetic readings were highest outside the mine entrance. If there's a nocturnal geophysical phenomenon, venting, vibration, magnetic fluctuation, I need overnight sensor data from inside the anomaly zone, not from base camp, a mile and a half away. You want to sleep in a narrow slot canyon with anomalous air quality and an unexplained presence that's been manipulating our campsite," Devin said. It wasn't a question. I want to collect data from the location where data collection will be most meaningful. And I don't want to sleep. I want to monitor instruments all night. I considered it. Maggie's reasoning was scientifically sound. The base camp sensors had captured 1 CO2 event and confirmed the overnight gas accumulation pattern. But the base camp was at the periphery of the anomaly. The core of whatever was happening was upstream, in the side drainage, near the mine. If we wanted answers, measurable, defensible, publishable answers, we needed data from the source. But Corinne's order had been clear about the mine, and her general instruction had been to withdraw at any sign of impairment. She hadn't specifically prohibited camping in the side drainage. It was within the scope of our survey authority. "Not tonight," I said. "Tomorrow night, if today's data review supports the plan and if Corinne approves. We move sensors up to the chamber in the morning, establish a monitoring position, and spend 1 night collecting data. Full watch rotation, full communication protocol, packs ready to move at any time." Maggie accepted this. Devin accepted it too. though the look he gave me said he would be spending the intervening 24 hours thinking of reasons to argue against it. The rest of the afternoon passed in careful, methodical work. Maggie downloaded and organized her instrument data, running preliminary analyses on her laptop that she had left at base camp. Devin and I completed a full re-inventory of our supplies and equipment, confirming that we had sufficient food, water purification, batteries, and first aid capability for 2 more full days in the field. I cleaned and checked the radio, confirming signal strength to the repeater. Devin replaced the batteries in both GPS units. At 5 o'clock, I made the scheduled radio check and briefed Corinne on Maggie's proposal for the overnight monitoring in the side drainage. Corinne was quiet for a long time. "What's your professional assessment?" she asked. "I think the geological data justifies it. The anomaly is real and it's centered on the side drainage. One night of monitoring from inside the anomaly zone could provide answers that we can't get from base camp." "And the other evidence? The tooth? The footprints?" "Unexplained but not threatening. We've had no direct encounter, no equipment damage, no physical threat. Whatever is happening in this drainage, it hasn't been aggressive." "That you know of," Corinne said. She was right, and I acknowledged it. "I'll approve it on conditions," she said. "First, you maintain radio contact on the hour, every hour, through the night. If I miss a check-in, I'm sending a SAR team at first light. Second, if anyone experiences any physiological or psychological symptoms, you abort immediately. Third, you carry everything out with you the following morning. I want the drainage clear by noon on day 4. That gives you 1 overnight, and then you're done." "Understood. And Ashcroft the tooth, did you bag it?" "Bagged and secured in my pack. Bring it out with you. I've already contacted the archaeologist. She's interested." I signed off and told the others. Devin nodded, his expression set. Maggie began planning her sensor deployment with the focused energy of someone who had been given exactly what she wanted. We ate dinner in the long shadow of the canyon as the light failed. The evening was quiet. The insects built their chorus gradually and maintained it without interruption. The creek ran steady. The air cooled in its familiar rapid descent as the sun dropped behind the rim. I took the first watch that night, midnight to 2. The camp was still, the stars brilliant, the canyon a corridor of black rock under a strip of sky. I listened for the rhythmic sounds I had heard the previous night. I listened for Devin's subsurface vibration. I listened for footsteps, for breathing, for any sound that didn't belong to the water and the insects, and the slow, patient metabolism of the canyon itself. At 12:50, I heard it. Not from upstream this time. From directly across the creek, maybe 40 feet away, at the base of the East Canyon wall. A single sound, brief and distinct. The sound of a stone being placed on another stone. A small, precise contact. Click. I held completely still. My eyes were adjusted to the dark, and I scanned the base of the wall opposite camp. The rock there was irregular, boulders, ledges, deep shadows between. I couldn't see anything that didn't look like rock, but I knew what stone on stone sounded like. Every ranger who has worked in cairn trail systems knows that sound. It's one of the most intentional sounds you encounter in the wilderness. Rocks don't place themselves on other rocks in the dark. I waited. 5 minutes. 10. Nothing else. No movement. No further sound. The insects continued without interruption. The creek ran. The canyon breathed its slow, mineral breath. At 1:15, I heard it again, the same sound. Click. Stone on stone. From the same direction, but slightly further upstream, maybe 60 feet from camp now, instead of 40. as though whatever had made the first sound had moved 20 feet to the north in the intervening 25 minutes and placed another stone. I weighed my options. I could illuminate the area with my headlamp and possibly see the source. This would sacrifice my night vision and alert whatever was there to my attention. Or I could remain still, continue to observe, and allow the behavior to continue uninterrupted. I chose to remain still. The sounds were not threatening. They were. And I reached for this word, carefully communicative, deliberate, placed with the same precision as the stone on our cairn, the tooth on the stone. Not random, not accidental. Intentional acts performed within earshot of an observer, as though the observer's presence was part of the purpose. At 1:40, a third click. Further upstream again. The source was moving along the base of the east wall in the direction of R7 and the side drainage. The intervals were irregular, 25 minutes between the first and second, 25 minutes between the second and third, but the distance covered seemed consistent. Roughly 20 feet per interval, a slow, steady progression upstream. I noted everything: time, estimated position, estimated interval, acoustic quality. The sound was identical each time. Same volume, same tonal character, same duration. A flat stone placed on another flat stone by something that did not vary its technique. At 2 o'clock, I woke Devon for his watch and described what I had heard. His face was difficult to read in the dark. 3 placements, he said. Moving upstream. Yes. Toward the side drainage. Yes. He settled into the watch position, and I went to my tent. I did not sleep. I lay in my bag with my ears open and listened to the canyon through the thin nylon of the tent wall. If Devon heard a 4th placement, he didn't wake me to report it. When dawn came, I was up immediately. Devon was sitting on the watch rock with his hands wrapped around a cold cup of coffee he had apparently made and then forgotten to drink. Maggie emerged from her tent within minutes, already alert. Anything? She asked Devon. 1 more, he said. At 2:20. Same sound, further upstream. I couldn't see anything. I crossed the creek and walked to the base of the east wall, where I'd estimated the first sound originated. The ground was rocky and uneven boulders ranging from basketball-sized to car-sized, interspersed with gravel and dry sediment. I searched for 15 minutes. I found it at the base of a waist-high boulder, 20 feet from the creek. A small, flat stone, maybe 3 inches across, resting on top of a slightly larger flat stone. Both were dark volcanic rock, indistinguishable from the thousands of similar stones in the drainage. But these 2 were stacked, deliberately. The upper stone centered on the lower one, with the same careful placement we had seen on the cairn. I continued upstream along the wall. 20 feet further, another pair. Same size, same placement. 20 feet beyond that, a third. And 20 feet beyond that, a 4th Devon's 220 placement. The most recent. The uppermost stone still cool from the night air, in a way that the morning sun had not yet corrected. 4 small cairns. 2 stones each. Evenly spaced along the base of the canyon wall, leading upstream toward R7. Placed in the dark, within earshot of our camp, by something that moved without being seen and built with a consistency that exceeded casual human behavior. Maggie examined each one without touching them. She measured the spacing 20 feet, 21 feet, 19 feet, 20 feet, nearly uniform. She measured the stone sizes all within a centimeter of each other. She measured the orientation all aligned the same way, with the long axis of each stone pointing upstream. "This is structured behavior," she said. Her voice was very calm. The voice of a scientist who has spent her career believing that everything has a physical explanation and is now standing in front of evidence that is testing that belief with considerable force. This is patterned, consistent, directional behavior with a precision that suggests either a compulsive human actor or something I don't have a framework for. Devin was standing at the creek's edge, looking at the line of small cairns along the wall. "It's marking a path," he said. "From camp to the side drainage. It's showing us the way." Nobody disagreed with him. Nobody could. The stones pointed upstream like cairns on a trail, because that is exactly what they were. Whatever had placed them was not hiding. It was not threatening. It was doing something far more unsettling. It was guiding us. I made the morning radio check and reported the overnight observations to Corinne. She listened, acknowledged each point, and then said something that changed the remainder of our time in the drainage. "Ashcroft. I sent a ranger up the Middle Fork Trail this morning to check the junction with Redstone Creek. He arrived at the confluence at 0730 and found fresh barefoot prints on the gravel bar. Multiple prints. Same estimated size you reported. They come from the direction of Redstone Creek and they stop at the river's edge. They don't continue across the Middle Fork or onto the opposite bank. Whoever made them walked downstream from your position to the confluence and then either entered the river or turned back." "When were they made?" He estimates overnight. The gravel bar floods during afternoon thunderstorm runoff and resets daily. These prints were on a clean surface. So while we were sleeping, someone walked barefoot from somewhere near our camp to the Middle Fork confluence and stopped. That's what the evidence shows. I looked at the 4 small cairns along the east wall. At the larger cairn at R5 with its added stone and its human tooth. At Devin, who had lost 42 minutes in this canyon. At Maggie, who had come here believing in magnetite and CO2 and was now standing in silence with her notebook closed. "We're still going up tonight," I said. "The side drainage, as planned." Corinne paused. "Confirmed. But Ashcroft, I want check-ins every hour on the hour starting at 2000. If I don't hear from you by 15 minutes past any scheduled check, I'm activating SAR." Understood. We spent the morning preparing. Maggie selected the sensors she would deploy in the footprint chamber magnetometer, CO2 monitor, temperature logger, a small seismometer she had brought but hadn't yet used, and an audio recorder. Devin packed emergency supplies, a compact bivvy for each of us, extra water, a first aid kit, a full set of spare batteries. I reviewed the route, confirmed our GPS waypoints, and verified the radio from the R7 cairn to make sure we could reach the repeater from inside the side drainage. The radio check from R7 was marginal. I could raise the repeater, but the signal was weak, broken by the canyon walls. Inside the side drainage itself, we would likely lose contact entirely. "We'll need to send someone back to the main canyon for each hourly check," I said. "I'll do it," Devin said. "I know the road. 5 minutes down to R7, make the call, 5 minutes back." It was the right plan. Devin was the fastest and most familiar with the terrain, and his volunteering for the exposed position, the one that required repeatedly walking alone through the dark canyon, told me that whatever fear he was carrying, his sense of professional duty was carrying more. We ascended the side drainage at 4 in the afternoon. Loaded with overnight gear and instruments, the passage through the narrow cleft felt different this time. Not more threatening exactly, more consequential, like the difference between visiting a house and agreeing to stay the night. The footprint chamber was unchanged. The circling prints in the fine sediment, the facing scratch marks on the walls, the cool, mineral-scented air moving downward from the mine above, Maggie set up her instruments with efficient precision, placing sensors at the 4 cardinal points of the oval footprint path and the seismometer in the center of the chamber, pressed firmly against the bare rock floor. Devin and I established our position at the upstream end of the chamber, where we could see both the continuing drainage toward the mine and the narrow passage back toward the main canyon. We laid out bivvies and organized our gear for a long night. The light faded early in the side drainage. By 6 o'clock, the walls were in full shadow, and the strip of sky above was dimming from blue to purple. By 7, it was dark enough to need headlamps for any task requiring visual precision. By 8, it was completely dark. The kind of absolute darkness that only exists underground or in deep, narrow canyons where the geometry blocks even starlight. Devin made the first radio check from R7 at 8 o'clock. He was gone for 12 minutes and returned without incident. "Corinne confirms," he said. "She's standing by." Maggie was watching her instruments. The magnetometer showed the same elevated readings as the previous day, stable and consistent. CO2 was ambient. Temperature was dropping 58 degrees at sensor height. The seismometer showed a flat trace. The audio recorder was running, capturing the ambient sound of the chamber, the faint drip of water from somewhere above, the whisper of air moving through the drainage, the occasional distant sound of Redstone Creek far below. At 8:40, Maggie said, "The magnetic field just shifted." Devin and I both looked at her. "Not the intensity," she clarified, "the direction. The field vector rotated about 15 degrees over the last 10 minutes. That shouldn't happen. The source is geological, it's in the rock. It doesn't move." She tapped the magnetometer's display. "Unless there's a secondary source that's mobile, or unless the primary source is behaving in a way that stationary magnetite deposits do not behave." "What could cause a field rotation in a static geological source?" I asked. "Nothing I know of," Maggie said. "In theory, a large conductive body moving through a magnetic field would alter the field geometry at a fixed observation point. But we're talking about rock. Rock doesn't move, not on a time scale of minutes." Devin's 9 o'clock radio check was uneventful. He left, made the call, returned. Corinne confirmed. The night continued. At 9:20, the seismometer registered its first event. The trace on the small screen jumped at a single sharp pulse, followed by a low-frequency oscillation that decayed over roughly 4 seconds. Maggie was on it immediately, adjusting the display scale to capture the full waveform. "That's not a microtremor," she said. "The frequency signature is wrong. Seismic events from tectonic or volcanic sources have characteristic frequency distributions broadband, with energy across a wide spectrum. This is narrowband, almost monochromatic, a single dominant frequency around 7 Hz. "What produces a 7 Hz signal?" I asked. "In geological contexts, fluid movement through constrained channels. Hydrothermal systems can generate narrow-band seismic signals when water or steam moves through fractures under pressure. But 7 Hz is low even for that. And the onset was too sharp. Hydrothermal signals usually build gradually as pressure increases. This started instantaneously, like something struck the rock." Devin was sitting very still against the chamber wall. "That's what I felt the other night. On watch, that vibration." "Could be," Maggie said. 7 Hz is right at the threshold of human perception. Most people would feel it as a chest sensation rather than hear it as sound. It's in the infrasound range below the normal frequency limit of human hearing, but within the sensitivity range of the vestibular system and certain internal organs. "Infrasound has documented psychological effects," I said. I had encountered the research during a training seminar years ago on unusual environmental hazards. The presenter had discussed how low-frequency sound waves, particularly in the range of 7 to 19 hertz, could induce feelings of unease, anxiety, and even visual disturbances in susceptible individuals. One researcher had famously traced a haunting in his laboratory to a standing infrasound wave generated by an improperly mounted ventilation fan. It does, Maggie confirmed. Vic Tandy's work. 7 hertz is particularly interesting because it's close to the resonant frequency of the human eyeball. Sustained exposure can cause peripheral visual disturbances, the sensation of seeing movement or shapes at the edge of your vision that aren't there. Combined with the magnetic anomaly and the elevated CO2, you'd have a trifecta of environmental factors that could produce a profound perceptual disturbance without any single factor reaching a level that would normally be considered dangerous. She said this with the controlled enthusiasm of a scientist whose hypothesis was assembling itself from live data. But I heard something else underneath a note of relief. Every anomaly that could be measured, quantified, and fitted to a known mechanism was an anomaly that didn't require other explanations. The magnetite was real. The CO2 was real. Now the infrasound was real. Each instrument that registered a reading was a vote for the comprehensible. The seismometer recorded 2 more events over the next 20 minutes. Both had the same signature sharp onset, narrowband oscillation at 7 hertz, 4 to 5 second decay. Maggie noted that the intervals were not regular. The first gap was 8 minutes, the second was 12. Not the mechanical periodicity you'd expect from a steady-state process like hydrothermal cycling. It's episodic, she said. Something is triggering these pulses. Pressure buildup and release in a subsurface cavity is the most likely mechanism, but the irregular timing suggests the system is complex, multiple chambers, variable flow paths. Devin left for the 10 o'clock radio check. The moment he disappeared through the narrow passage downstream, the chamber felt smaller. Not physically, the walls hadn't moved, but the awareness of being 2 people instead of 3 in a dark stone room beneath a mountain changed the psychological geometry of the space. I found myself listening harder, watching the dark passage where Devin had gone, counting seconds until he returned. Maggie noticed. He'll be fine. The route between here and R7 is straightforward. I know. You're doing the thing experienced people do. You're managing everyone's risk in your head simultaneously, and the math gets worse every time someone is out of sight. She was exactly right. And the fact that she could identify it told me she had worked with enough field teams to recognize the pattern. I appreciated the observation without acknowledging it directly. Devin returned at 10:12. Corinne confirms. All quiet at the station. She says the ranger she sent to the Middle Fork found 1 more set of prints today. Upstream of the confluence this time. Barefoot, same size, heading toward us. The 3 of us sat with that information in the dark chamber. Whoever was making those prints was moving up and down the drainage between the Middle Fork and our position, barefoot, at night, without being seen. The canyon was a linear system, 1 way in, 1 way out, unless you climbed the walls and traversed the rim. A person moving along the creek corridor should have been visible or at least audible to anyone else in the corridor. We had been in the drainage for 3 days and had never seen another human being. I want to address something directly, Maggie said. She turned off her headlamp and sat in the darkness. I heard her shift against the rock wall. We have 3 categories of evidence. The first category is geophysical, the magnetic anomaly, the CO2 accumulation, the infrasound pulses. That evidence is instrumental, repeatable, and explainable within known science. The second category is the historical human activity. The mine, the worn rock, the scratch marks, the circling footprints. That evidence is physical and documented, but the behavior it represents is unexplained. The third category is the ongoing anomalous activity, the cairn additions, the moved sensor, the tooth, the barefoot prints, the sounds Ashcroft heard. That evidence suggests an active agent operating in this drainage concurrent with our presence. She paused. The darkness was absolute. I could hear her breathing, and Devon's breathing, and the faint movement of air through the chamber. Categories 1 and 2 might be connected, she continued. The geophysical conditions in this drainage are unusual enough that they could plausibly influence human behavior in the ways we've observed the circling, the disorientation, the compulsive repetitive activity. If someone in the past spent significant time in this environment, exposed to the magnetic field and the infrasound, and the CO2, the behavioral effects could have been substantial. That might explain the worn rock at the mine entrance, the footprint patterns, even the scratch marks, if we interpret them as compulsive marking behavior. And Category 3? Devon asked. Maggie was quiet for a moment. Category 3 is harder. If there's a living person in this drainage exhibiting the same behaviors, then we might be observing someone who is currently being affected by these same environmental conditions. A person living rough in this canyon, exposed chronically to the anomalous zone, could develop the kind of compulsive pattern behavior we're seeing, the circling, the barefoot walking, the stone placement. A person we can't see, Devon said. A person who doesn't leave tracks except when they choose to. A person who moved a 2-pound sensor and placed a human tooth on a cairn while 3 rangers were asleep 40 feet away. I didn't say it was a comfortable explanation, Maggie said. I said it was the one that stays within the bounds of what I can professionally defend. I respected that. Maggie was drawing a line. Here is where my expertise reaches, here is where it doesn't, and she was honest about both sides. She wasn't claiming the geophysical data explained everything. She was claiming it explained everything she was qualified to explain, and she was leaving the rest undisguised. We maintain observation, I said. We document. We don't theorize beyond the evidence. The seismometer pulsed again at 10:31. Same signature, 7 Hertz, sharp onset. But this time the decay was longer, nearly 8 seconds, and Maggie noted that the amplitude was higher. The source was either closer, more energetic, or both. Then at 10:40, the magnetic field did something Maggie had never seen. It's oscillating, she said. I heard her move toward the instrument in the dark. The click of a headlamp. A cone of red light illuminated the magnetometer's display. The field strength reading was not stable. It was cycling, rising and falling in a rhythmic pattern with a period of approximately 12 seconds. Up, down, like breathing. That's not possible, Maggie said. She said it flatly, without drama, the way you state a fact. A geological magnetic source does not oscillate. Magnetite is a permanent magnet. Its field is static. There is no mechanism by which a static magnetic source embedded in rock produces a rhythmic field variation. Unless the source isn't static, I said. The source is rock. Is it? She didn't answer immediately. She watched the display cycle through 4 more oscillations, then checked the period with her watch. 11.8 seconds, 11.9, 12.1, 12 seconds, nearly constant. A 12-second cycle is significant, she said, and her voice had changed. The scientific confidence was still there, but it was sharing space with something else, a humility that came from standing at the edge of her knowledge and looking past it. 12 seconds is the dominant period of ocean microseisms, the constant low-frequency vibration of the Earth's crust generated by ocean wave activity. It's detectable everywhere on the planet, even thousands of miles from the coast. The Earth literally has a 12-second pulse. But that's a seismic signal, not a magnetic one. There's no known coupling mechanism between seismic microseisms and local magnetic field variations. Could the magnetite deposit be moving? Devin asked. If the rock is vibrating at that frequency and the magnetite is in the rock, would the field oscillate? Maggie considered this. Theoretically, if the entire deposit were physically oscillating, shifting position by even a fraction of a millimeter at a 12-second period, the field at a nearby observation point would vary accordingly. But you'd need a seismic energy input sufficient to move a massive rock body, and the seismometer should be showing that. Let me check. She moved to the seismometer and examined the trace. The seismometer is showing the 7 Hz pulses we already documented, but there's no 12-second signal in the seismic data. Whatever is driving the magnetic oscillation, it's not mechanical vibration of the rock. We sat with that. 3 instruments in a dark stone chamber, one measuring a magnetic field that was behaving impossibly, one measuring infrasound pulses from an irregular subsurface source, one measuring CO2 that was, as of Maggie's last check, now reading 940 parts per million at ground level in the chamber elevated, approaching the range where subtle cognitive effects become possible during prolonged exposure. We should consider the possibility that the elevated CO2 is affecting our instrument interpretation, Maggie said. She said it reluctantly, as a scientist who trusts her data, but also trusts the principle that the observer is part of the observation. At 900 parts per million, we're still well below symptomatic levels. But the threshold for subtle cognitive effects impaired judgment, reduced critical thinking, is debated in the literature. Some researchers put it as low as 1,000 parts per million. Are you saying we might be misreading the instruments? I'm saying we should acknowledge the possibility and factor it into our confidence level. The readings are what they are. But our interpretation of what they mean could be colored by conditions we're not fully perceiving. It was the most honest thing anyone said that night. Devin left for the 11 o'clock radio check. Maggie and I waited in the chamber. The magnetic oscillation continued steady, 12-second period, unchanging amplitude. The seismometer recorded another infrasound pulse at 10:58, this one with a slightly different character. The decay was shorter, and there was a secondary pulse about 2 seconds after the primary, like an echo. Though Maggie said subsurface seismic echoes at this frequency range would require a reflecting boundary, a cavity wall, or a density change in the rock at a specific distance from the source. How far? I asked. At 7 Hz in basaltic rock, a 2-second echo delay corresponds to a reflector at approximately 14 meters. That's the distance from the source to a wall and back. She looked at the rock surrounding us. If the source is somewhere below this chamber, the reflecting surface could be the far wall of a cavity at about 7 meters from the source. That's a big cavity. Mine workings? Could be. The mine adit is above us and presumably extends into the rock in some direction. If there are chambers or stopes, excavated areas where ore was removed, they could be the reflecting boundaries. Devin's return at 11:13 was faster than usual. He came through the narrow passage breathing harder than the exertion warranted. "Someone is on the trail," he said. Maggie and I both went still. "Describe what you observed," I said. Devin sat down and took a breath. I reached R7 and made the radio check. Corinne confirmed. On the way back, about halfway between R7 and the side drainage entrance, I heard footsteps in the main canyon, upstream of my position, moving toward me. moving toward you, in the main canyon. Yes, steady walking pace. Barefoot on gravel, that distinctive sound, the grit compression without the boot sole slap. I stopped and listened. The footsteps continued for maybe 10 seconds and then stopped. Distance. Close. 50 yards at most. The canyon is narrow there and the acoustics are clear. 50 yards. Did you illuminate? I turned on my headlamp and swept the canyon. The beam reached well past the distance I estimated. There was nothing there. No person, no animal, nothing moving. The creek, the rock, the trail, empty. And the footsteps stopped when you turned on the light. Devin paused. He recognized what I was implying, that the cessation of sound coincided with visual observation, which could suggest the source was responsive to being watched. They stopped before I turned on the light, he said. I stopped walking, listened. The footsteps continued for a few seconds, then they stopped. Then I waited, maybe 5 seconds, and then I turned on the headlamp. The sequence was, I stop. Footsteps continue. Footsteps stop. Pause. Light on. Nothing there. So the source stopped independently, not in response to the light. That's how it happened. Maggie asked, could the sound have been an echo of your own footsteps? The canyon walls could produce a delayed reflection. Devin shook his head. I've walked that section dozens of times. I know what my echo sounds like. This was a different rhythm than my own pace, and it continued after I stopped. An echo doesn't outlast its source. We were all awake now in a way that transcended the caffeine Devin had brought in his thermos or the adrenaline of a field anomaly. The alertness was deeper than that. It was the state your nervous system enters when it has accepted that the environment contains something it cannot model and therefore cannot predict. The midnight radio check was mine. I told Maggie and Devin I would go, and I told them to remain in the chamber with the instruments. I took my headlamp, set to red light to preserve night vision, and descended through the narrow drainage toward the main canyon. The route was about 200 yards. Through the second narrow passage, past the spring, down the steep section, through the squeeze between the close walls, and out onto the Redstone Creek Trail at R7. I knew the terrain now. My feet found the route without much help from the lamp. The drainage was quiet. The air moving past me from above carried the same mineral scent it always did, and the temperature dropped as I descended from the slightly warmer chamber to the cold creek-level air of the main canyon. I reached R7 and keyed the radio. Corinne answered on the first call. I reported the continued seismic and magnetic anomalies, the elevated CO2, and Devin's auditory contact. Corinne copied everything. Ashcroft, she said, I've been thinking about this all evening. The evidence you're describing, the stone placements, the footprints, the tooth, the sounds, it reads like territory marking, like something establishing boundaries or waypoints. Has that occurred to you? It had. The small cairns along the east wall, spaced evenly, pointing upstream. The stone added to the existing R5 cairn. The scratch marks at regular intervals along the canyon walls and paired at the chamber entrance like gateposts, even the tooth placed on the cairn like an offering or a credential. All of it suggested demarcation, identification, the behavior of something claiming a space or defining a route through it. It has, I said. But territory marking implies a territorial entity, and we haven't identified one. I know. I'm just telling you what pattern I see from the outside. She paused. Be careful tonight. Check in at 0100. I signed off and stood at the R7 cairn for a moment, listening. The main canyon was dark and still. The creek made its constant low murmur. The air was cold on my face. I turned off my headlamp and let my eyes adjust. The canyon was a corridor of dim shapes, the pale line of the creek, the dark mass of the walls, the faint differentiation between rock and sky high above. I could see perhaps 30 yards in each direction before the darkness became total. I heard nothing. No footsteps, no stone placements, no infrasound vibration. The canyon was, for this moment, exactly what it appeared to be, a narrow volcanic drainage in the mountains of New Mexico. Ancient and silent and empty. Except it wasn't empty, I knew that. The evidence was overwhelming that something was active in this corridor. Something that moved at night. Something that built and placed and walked and circled with a patience and precision that did not match any wildlife behavior in my experience and did not comfortably match any human behavior either. Maggie's geophysical data offered a partial framework. The environment itself was unusual enough to influence perception and behavior. But the active agency we were observing went beyond the passive influence of magnetic fields and gas concentrations. Stones don't stack themselves because the local magnetic field is anomalous. Teeth don't migrate from mines to cairns because the CO2 is elevated. I climbed back up the side drainage to the chamber. The return felt longer than the descent, partly because I was climbing, and partly because the darkness in the narrow cleft was the densest I had experienced in the drainage. My red headlamp created a cone of dim visibility that extended perhaps 10 feet and made the rock walls look like the interior of a throat. When I reached the chamber, Maggie was kneeling beside the seismometer with her headlamp off. "Listen," she said. I turned off my lamp and listened. Devin was sitting against the wall with his eyes closed, not sleeping, concentrating. I heard it. Not through my ears, through my sternum. A low, sustained vibration that was below sound and above stillness. It wasn't pulsing like the earlier seismic events. It was continuous. A hum, if a hum could exist below the range of hearing. It filled the chamber the way temperature fills a room, uniformly, without direction, without source. "When did this start?" I asked. 3 minutes ago, Maggie said. "The seismometer is showing a continuous signal. Same 7 Hz frequency, but sustained instead of pulsed. And the magnetic oscillation has increased in amplitude. The field is swinging wider." I could feel the vibration in my teeth, in my fingertips where they rested on the rock floor. The chamber itself was resonating, the stone walls and floor acting as a membrane for whatever was generating the signal below. "This is the mine," Maggie said. "Whatever cavity system exists below and behind us, the mine workings, natural chambers, the connected spaces, something in that system is producing a sustained infrasound emission. The rock is transmitting it to us." What could produce sustained infrasound underground? Fluid resonance. If there's a water-filled chamber at the right dimensions, it could resonate at its natural frequency when disturbed, like blowing across the top of a bottle. The chamber geometry determines the frequency, and the fluid movement provides the energy input. At 7 Hz, the chamber would need to be, she calculated silently, roughly 20 meters in its longest dimension. That's a big space, but not impossible for a mine with expanded stopes or for a natural lava tube connected to the mine workings. The vibration intensified, not dramatically, a gradual increase, like someone slowly turning up a dial. I felt it in my chest now, a pressure that was not painful but was deeply, fundamentally uncomfortable, in a way that had nothing to do with pain and everything to do with the body's conviction that something it could not see was very close. Devin opened his eyes. "The footprint path," he said. I looked at the floor. In the red glow of Maggie's headlamp, which she had just turned on to check her instruments, the circling footprints in the fine sediment were visible, the layered oval path that someone had walked over and over. And I understood, suddenly and completely, what Devon was suggesting: the circling, the compulsive walking in ovals at the mine entrance and in this chamber, the worn rock, the mechanical pace of Devon's GPS track through the R7 to R9 corridor. It was not random behavior, and it was not ritual behavior. It was a response, a physical, neurological response to the infrasound and the magnetic field and the environmental conditions in the anomaly zone. The body, affected by forces it could not consciously perceive, translating that influence into movement, repetitive, patterned, self-perpetuating movement. Walking in circles because something in the deep structure of the nervous system was being driven to walk in circles. The hikers who reported disorientation, I said. The woman who said the land had shifted. She wasn't disoriented. She was feeling the onset of the same response. The environment was beginning to override her voluntary navigation. And Devon's missing 42 minutes, Maggie said. She was looking at him with an expression that combined professional recognition with personal concern. You walked through the anomaly zone in a state of altered consciousness induced by the combined environmental factors. Your body navigated because the repetitive motor pattern didn't require conscious input. But your hippocampus, the memory formation center, was disrupted, probably by the magnetic field. There's direct experimental evidence that magnetic fields can interfere with hippocampal function in animal models. Devon's face in the red light was very still. He was hearing, for the first time, a coherent explanation for what had happened to him. And the explanation was both reassuring and deeply disturbing. Reassuring because it had a mechanism. Disturbing because the mechanism meant that this environment could reach inside your brain and alter its function without your knowledge or consent. The previous visitors, I said. The person who wore the rock smooth at the mine entrance. They weren't choosing to walk in circles. They were being compelled by the environment. Compelled is a strong word, Maggie said. Influenced and trained. The nervous system responding to sustained environmental stimuli in a way that produces repetitive motor behavior. It's not mind control. It's more like, have you ever noticed that people walking in a group unconsciously synchronize their footsteps? Or that a person sitting in a room with a ticking clock will unconsciously match their breathing to the tick rate? The body entrains to rhythmic environmental inputs. What's happening here is the same principle, but the inputs are geophysical rather than social. And the effects are more profound because the field strengths and frequencies are more extreme. The vibrations stopped. Not gradually, instantaneously. One moment the chamber hummed with it. The next moment the air was still and the rock was silent, and the only sound was the three of us breathing. Maggie checked the seismometer. Signal gone. Flat trace. The magnetic oscillation has stopped too. Field strength is back to the static elevated baseline. The silence felt larger than silence usually does. It felt like the space left behind when something living leaves a room. Devon made the 1 o'clock radio check. He was gone for 14 minutes this time, 2 minutes longer than usual, and when he returned, his breathing was controlled, but his pupils were dilated in the red light. I heard it again, he said. The footsteps. Same location in the main canyon. But this time, they were going the other direction. Downstream, away from us. Moving fast, a jog or a run. Barefoot on gravel. The sound lasted about 5 seconds, and then nothing. Moving away from us, Maggie repeated. Downstream, toward the middle fork. Nobody spoke for a while. The chamber was still. Maggie's instruments showed baseline readings, the elevated but static magnetic field. Ambient CO2 slowly climbing in the closed space. No seismic activity. At 1:20, I heard a new sound. Not from below, not from the main canyon. From above, from the direction of the mine. A scraping, brief, the sound of something moving across rock. Not footsteps, more like something being dragged. A single scrape, maybe 2 seconds long, and then silence. All three of us heard it. All three headlamps pointed upstream, toward the narrow passage that led from the chamber up to the mine shelf. That came from inside the mine, Devin said. His voice was barely above a whisper, not from fear, but from the instinct to minimize one's acoustic signature in the presence of something unknown. Maggie picked up her magnetometer and held it toward the upstream passage. The display was steady, no change. Whatever had made the sound had not altered the magnetic environment. Could be rock settling, Maggie said. Old mines shift constantly. Temperature changes cause expansion and contraction. Timbers degrade. Gravity works on loose material. A rockfall inside an abandoned mine is one of the most common sounds in mining country. At 1:20 in the morning, Devin said. The same night we're sitting 100 feet from the entrance. Coincidence of timing doesn't change the physics, Maggie said, but there was no conviction in it. She was defending the framework because the framework was all she had. And she knew it. And she knew we knew it. I made a decision. We maintain position until 0400. At 0400, regardless of conditions, we pack up and descend to base camp. We break camp at first light and hike out to the trailhead. We have enough data to support a preliminary report to Corinne and to justify a follow-up investigation with proper equipment, confined space entry gear, a larger team, extended monitoring capability. Maggie started to protest and then didn't. She looked at her instruments, at the rock walls of the chamber, at the dark passage leading up toward the mine, and she nodded. Agreed. But I want the sensors running until we leave. Every minute of data matters. Devin simply said, good. The hours between 1:30 and 4 were the longest of the survey. We maintained watch in shifts, one person monitoring instruments, one person watching the passages, one person resting without sleeping. The infrasound resumed twice more, once at 2:15 and once at 3:05, both times as sustained episodes lasting 6 to 8 minutes. The magnetic oscillation accompanied each episode with the same 12-second period. During the 3:05 event, the CO2 reading at ground level in the chamber reached 1,040 parts per million, the first time it had crossed the 1,000 parts per million threshold. We're now in the range where subtle cognitive effects are possible, Maggie said during the second event. I want all three of us to do a self-assessment. Any headache, nausea, confusion, visual disturbance, difficulty concentrating? I checked myself carefully. No headache, no nausea. My thinking felt clear. My vision in the red light of the headlamp was normal. I did notice one thing, a persistent feeling of being slightly off balance, as though the floor of the chamber had tilted a degree or two to the left. I mentioned it. Vestibular disruption, Maggie said. Consistent with the magnetic field and the infrasound. Your inner ear is being influenced by the environmental conditions. The brain interprets the conflicting vestibular signal as a tilt that doesn't match your visual and proprioceptive input. She checked herself. I'm feeling it too. Slight leftward lean sensation. Devin reported the same thing. All three of us perceiving the same directional tilt confirms it's environmental, not individual, Maggie said. If it were psychological or random, we'd expect different people to report different directions. The consistency indicates a real physical input, probably the magnetic field vector, which is oriented roughly east to west in this chamber. At 3:45, 20 minutes after the second infrasound episode ended, and 15 minutes before our planned departure, I was sitting watch at the downstream passage when I heard the stone-on-stone sound. Click. From inside the chamber, behind me, I turned. Maggie was at the instruments. Devon was at the upstream passage. Neither of them had moved. Neither of them appeared to have dropped anything or knocked anything against the rock. "Did you hear that?" I said. They both had. We searched the chamber with headlamps. The circling footprints in the sediment were undisturbed. The instruments were in their positions. Our gear was where we had left it. It took Devon to find it. He was checking the chamber walls, running his lamp along the base of the rock where the floor met the wall. And he stopped at a point on the north side of the chamber, the wall closest to the mine. Another tooth. A human premolar this time. Smaller than the molar we had found on the cairn, but with the same aged appearance, yellowed enamel, darkened root, no tissue. It was sitting on a small natural ledge in the rock wall at knee height, a ledge that had been empty when we set up in the chamber hours earlier. I was certain of this, because I had placed a temperature sensor on that same ledge at 7 o'clock, and had moved it to a better position at 8. The tooth was where the sensor had been, placed on the small rock ledge with the same deliberate precision we had seen in every other placement, oriented with the crown facing outward, as though displayed. We were in a sealed chamber. The only access points were the two narrow passages, one leading down to the main canyon, one leading up to the mine. One of us had been watching each passage continuously. Nothing had entered the chamber. Nothing had passed us. And yet a human tooth had appeared on a rock ledge that had been empty an hour ago. Maggie picked it up. I didn't stop her. The protocols about not handling evidence felt distant and theoretical in a dark stone chamber at 3:50 in the morning, with the mountain humming beneath us. She examined it under her headlamp. Same preservation state as the first one, old, decades old. The root shows no sign of extraction damage, no plier marks, no fracture patterns consistent with dental tools. This tooth came out of a jaw naturally, either post-mortem decomposition or advanced periodontal disease. "Put it in a sample bag," I said. "We're leaving." We packed in 12 minutes. Instruments, sensors, bivvies, all of it secured and loaded. Devon went first through the downstream passage. Maggie second. I came last, and before I left the chamber, I turned and swept my headlamp across the space one final time. The footprints in the sediment were exactly as they had been. The oval path, the layered circuits, the facing scratch marks on the walls, everything was the same. Except for one detail that stopped me for 3 full seconds before I turned and followed the others down. There was a new footprint. A single bare footprint in the fine sediment, inside the oval path, facing the upstream passage, facing the mine. It had not been there when we arrived. It had not been there at any point during the night when I had examined the floor. It was deep, sharp-edged, fresh, and it was not the same size as the others. The circling prints were large size 11 or 12. This single new print was smaller, size 9 maybe, a different foot, a different person. I did not mention this to Maggie or Devon. Not because I wanted to withhold evidence, but because in that moment, descending through a dark volcanic cleft toward a canyon that contained things I could no longer organize into professional categories, I needed to carry one piece of information that was mine alone. One observation that I could hold and examine without the immediate pressure of another person's interpretation shaping how I understood it. A second set of feet? A second individual, smaller, standing still while the others circled. We reached base camp at 4:30 in the pre-dawn dark. We packed out everything: tents, food, sensors, the bagged teeth, Maggie's data, and began the downstream hike by 5:15, moving fast in the gray light. None of us spoke much. The canyon opened gradually as we descended, the walls dropping, the light increasing, the creek widening. By the time we reached the Middle Fork confluence at 7, the morning sun was on the water, and the cottonwoods were bright, and the valley was wide and warm and ordinary. Devin stopped at the gravel bar and looked down. Fresh, barefoot prints in the damp sand, leading downstream to the river's edge and stopping. The same prints the other ranger had found. Large, deep, ending at the water as though the person who made them had walked into the river and dissolved. We hiked out in silence. The 4 miles to the trailhead passed quickly. The trail was dry and easy, and the sunlight was uncomplicated, and the world outside Redstone Creek Canyon was the world I had spent 30 years trusting, measurable, navigable, comprehensible. Corinne met us at the trailhead. She took one look at the three of us and didn't ask how it went. She took the bagged teeth, the data drives, and our written notes, and put them in a lockbox in the station. The debriefing took 4 hours. Each of us gave a separate account. Then we convened together to compare observations. Corinne recorded everything. Maggie produced her data, the magnetic readings, the CO2 profiles, the seismic traces, the magnetic oscillation record, and walked Corinne through the findings with professional clarity. She presented the geophysical framework: a concentrated magnetite body, a geothermally active subsurface system producing CO2 and infrasound, environmental conditions sufficient to produce perceptual and behavioral disturbances in exposed individuals. And the teeth? Corinne asked. The cairnstones? The footprints? Maggie was silent for a moment. Those observations are outside the scope of my geophysical analysis. They suggest the presence of an unidentified individual in the drainage, whose behavior includes repetitive patterned movement and deliberate placement of objects. I cannot offer a geophysical explanation for that behavior. Could the individual be a person affected by the environmental conditions? Corinne asked. It's possible. Chronic exposure to the anomaly zone could produce compulsive repetitive behavior. But several aspects of the observations, the precision of the placements, the ability to move undetected, the apparent awareness of our presence and schedule, suggest a level of cognitive function that's inconsistent with someone in an environmentally induced altered state. Corinne turned to Devin. You said something in your account that I want to revisit. You said the canyon wants you to walk in circles. You attributed that phrase to the 1997 Ranger, Esterhaus. But then you said that after spending time in the side drainage, you understood what he meant. Devin nodded. The vibration, the infrasound. When you're in that chamber and the mountain is humming, there's a pull. Not a physical pull, a directional impulse. Your body wants to move. And the shape it wants to move in is a circle. I didn't walk in circles. I didn't have a memory gap. But I felt the beginning of what could become that, if you stayed long enough. If you didn't have other people there to anchor you. Corinne wrote that down and closed her notebook. The forest archaeologist examined the teeth the following week. Both were human. Both showed age-related wear and discoloration consistent with the late 19th century based on dental morphology, though precise dating required laboratory analysis. She submitted them to the State Archaeological Office for evaluation. I never received the results. Maggie published a paper the following year in the Journal of Geophysical Research. It documented the magnetic anomaly and the CO2 accumulation pattern in the Redstone Creek drainage, and proposed a geothermal mechanism for the infrasound observations. The paper was well received within her field. It did not mention the teeth, the footprints, the cairn additions, or the stone-on-stone sounds. When I asked her about the omission, she said simply that those observations were outside the scope of her data, and she would not speculate in a peer-reviewed publication. I respected that. I also understood it to mean that she had no explanation for them and did not want to pretend otherwise in print. Devon Park finished the season and returned for a third year at the Gila in 2012. As far as I know, he did not go back up Redstone Creek. But Corinne told me in a phone call that December that Devon had taken to doing something he'd never done before, walking a slow loop around the station building's perimeter every evening before dark. Not a patrol, not exercise, a loop. The same path every time, the same direction, the same pace. When she asked him about it, he said it helped him think. Corinne closed the Redstone Creek drainage to recreational use in September of 2011, citing hazardous trail conditions and potential geothermal gas risk. The closure has been renewed every year since, as far as I'm aware. The official reason is public safety. And that is true. It is just not the complete reason. I think about that drainage more often than I'd expect. Not with fear, not with the urgent curiosity I felt during those 4 days. More with the awareness that we walked into a place where the earth itself was doing something we could partially measure and partially understand and partially feel in our bones. And that in the gaps between those partial understandings, something else was operating. Something that walked barefoot and built small, careful structures in the dark. And left human teeth like calling cards. And moved without being seen and hummed beneath the rock in a frequency that made your body want to trace the same path over and over until the path wore smooth. Maggie gave me the measurable part. Devon gave me the human part. The canyon kept the rest. I still have the GPS track from Devon's May survey on a hard drive somewhere. The one that shows him walking the 2-mile stretch between R7 and R9 at a perfectly constant 2.4 miles per hour without a single variation in pace. Sometimes I think about opening that file and looking at it again. I never do. Some data is harder to carry than the questions it was supposed to answer. And sometimes, when I'm walking a trail alone, and the light is low and the air goes still in a way that feels less like calm and more like attention, I notice something in my stride. A pull, not forward, not backward, to the side, the faintest directional impulse, asking my feet to curve, to arc, to begin a shape my conscious mind did not choose. When that happens, I stop walking. I stand still. I wait for it to pass. It always passes. But I never forget that somewhere in the Gila, in a canyon of black rock where the earth hums at 7 hertz, the path is still worn smooth, and the footprints in the chamber are still circling. And whatever placed those teeth in the dark, with a patience that outlasts every season and every survey and every ranger brave enough or foolish enough to spend a night in its architecture, whatever that is, it is still walking. And it is still waiting for someone to walk with it.